There you go. Hi, people. How are you? Nice to see you. Hi, Internet. If we have video, just confirm. If we don't have video, I will stop saying hi. Hello, Internet. How are you, people? I don't see you like in 2 weeks. So, did you have fun? Was it good? Yes? No? Okay, you can tell me later. They're here. It's fine. It's fine. You can give me anonymous feedback. So, Internet, how are you? Welcome back. We are going to be reading you in the chat. And oh, yeah, I have my thing out. So, probably this is why you don't see anything in your video. So, after some weeks that I was traveling, actually, I saw some of you people online in Argentina in Eco Party. Hi, how are you, people? Huh? Oh, it's not the live. Okay, okay. So, and are we recording this? We don't know. It's recording. Okay, there you go. Perfect. But still not online the video. Okay, so. Tell me when you're back, Internet. If you see this later, hi, how are you, people? Nice to see you. What is going on? We have like stuff happening. That was weird. I was getting out from the speaker. Ooh, spooky class today. Yeah. Let's see if the gods of the classes and demos are with us today. We need some candles in here. So we are going to have our class number 10 today. I can see that some of you are probably on holiday or preparing for the exams or just give up on the class. We'll see later. Where are you? Or maybe you are traveling too. If you're traveling, that's a good idea. And as you can see, also some of us are taking some time off to prepare and to recover. So Mari and Vero are not here with us today. Lukashi is up there, so he's here. We are going to have the class Automating Attacks with Malware, class number 10. And you can see the awesome, amazing animation, no? But drawing of Fermin, the one where we attack all the things. November 28, and they have the credits as always, and the links and the links and the links. This should all be working. Are we still in streaming? Working on it. Okay. I will slowly get into the intro then. So before starting, the results from the survey of the last class. That was the class that was done by Maurice here. Thank you very much, Maurice. What do you think about Maurice's class? Was it good? Complex, right? Yeah, yeah. Such hard topics, right? You are there reversing. Oh my God. But it was beautiful. Thank you very much. And before the class of Martin also, what do you think? Martin is very, very busy. He's not going to listen to you. But what do you think? Was it a nice class? Yeah? I like it too. Also tough one. Also tough one. I'm super happy. And part of, okay, I will tell you later. So how was the class tempo? It was all right. Too slow? No, it was perfect, the tempo. Only 9 responses. Again, Internet, when you see this later, even if you are taking this class in 2 weeks or 3 weeks, please go and fill the feedback at the end and tell us how it was for you. The feedback you're giving is not only for the next class here, but even for the next year, okay? So please go and tell us what you think. If you are taking a class that's like 2-3 weeks old, you can tell us, hey, this is for class number 7, and that's gonna feel fine. So, some Parish notices. The first one is I wanted to thank the team because honestly, I know that I say this often, but without the team behind everything, that this class is not possible, like me traveling to Argentina and back. So I'm very lucky to have all the team behind. So thank you very much. Thank you very much, Ondro, Lucas, and Mari, and Vero, and Martin, and everybody. And also the students abroad, thank you very much. You that were online, we were there in Argentina, and I met with some of you, and you were very kind to us and telling all of you, team, how they enjoy the class. So thank you very much, Internet. And actually, we were very lucky because one of the students online, Internet students, was very generous because they, she, he, it doesn't matter, he, she wants to remain anonymous. In Eco Party, was playing one of the CTFs, and after playing the CTF, got one of the badges of the CTF, and anonymously donated the badge as the first Pioneer Prize for this week. So that's coming from one of the online students. So thank you very much, Anonymous Students number 1. And with that, we are going to be moving into the Pioneer Prizes. Yeah, before this, if you're online, please start the class number 10, because it's going to take some time. If you go here and you press, if you press, I'm going to make this a little bit bigger, bigger, something like that. If you press start, it's going to take probably like 5 minutes to start the Stratosphere CyberLab, because now we have many Dockers download for today, okay? So be sure that you're doing that. So, and with that, we can go to the Pioneer Prizes. Are we online or not? Yes? Perfect. So there you go. Hi, Internet. How are you? Sorry for the coming a little bit later. And also I wanted to say that for the questions today, Veronica's not here, but she 3D printed small Mandos. Do you know Mandos? Mando. Hey, Mando! No? Do you know who Mando is? Nobody knows who Mando is. Oh, come on. This cannot be more modern than this. No? Star Wars, did you hear about Star Wars? Mandalorian, yes, Mandalorian. Nobody saw Mandalorian. Mando is Mandalorian. Hi, Mando. There you go. You have 3 small 3D printed Mandalorians for you. Only good questions coming from Veronica. Thank you very much. So, Pioneer Prizes for last week assignment. Anything we want to say about the last week assignment? New things that happened, crazy things. Do we remember something? Was it fast? No?
I mean, people were kind of depressed with reversing during the class, but they still managed to do the assignment, so it's good. You know, it wasn't maybe that difficult. It was just a lot, I guess.
Yeah. So we are
pretty well.
Yeah, we are very happy actually to do the assignment, or those of you who did the assignment, because it was very, very interesting. So we have the 3rd place, a Raspberry Pi Pico. Wow, we're in the moment that the Raspberry Pi Pico is the 3rd place. Wow, that is nice. So we have a Raspberry Pi. 2 third places. What? But they're sharing one Raspberry Pi Pico? Oh, wow. We have 2 Raspberry Pi Pico. This is getting more and more. And the 2 third places are for Lukasz and David. Bravo. Kaufmlu and Kostada 2. Bravo, bravo, bravo. So lucky you don't have to share the Raspberry Pi Pico. Small computer. You can run MicroPython. You can run CircuitPython. There you go. Hope you enjoyed. And you can hack more. And the 2nd place goes to, it's actually an RFID reader with an antenna, 125 kilohertz, and a lot. And it's going to Tomasz Wesel 27. Bravo, Tomasz. Well done, well done. And the first prize, the awesome electronic badge with games and buttons and batteries, and including a Raspberry Pi Pico inside with Wi-Fi, goes to Rostislav Quadro 2. Bravo, bravo. Where are you? Oh, no. Yes, sure. No problem. I mean, 2 minutes maybe, we will see, and if not, sorry? He said first break. No, first break, this is gone by the first break. Okay, we will see. Congratulations, people, on this one. So, the class goal is going to be, it is to understand why automation is needed in security and how malware can be automated, okay? So actually we are in a place that we saw a lot of attacks, we saw a lot of exploiting, reversing, binary exploitation, many techniques, and I know that for some of you this is a lot, right? A lot. So we are in a place that, okay, that's awesome, but how can we automate this? I don't want to be typing every time, right? So that's going to be the topic today. And I want to do a parenthesis when I said this about the people doing it a little bit later. Again, I want to thank you, everyone in the internet, when you're taking this class. Not only later, several weeks, but also in parts because they don't have the time. So a lot of people was telling us, oh, I'm taking it half an hour on Thursday and then 10 minutes on Saturday and then an hour on Sunday. It's like, wow, wow. And they were doing the challenges and sitting and learning. I learned that many companies gave extra time off only for doing the class. So it's not only the time of the class plus hours of learning and studying. I was very happy because actually it's tough, but yeah, we are happy they are doing it. So thank you very much, Internet. So if you follow, this is not the best color. Now I'm learning a little bit late, but we went from the beginning of the class from finding computers, getting access, detecting intruders, honeypots, virtual machines, threat intelligence, privilege escalation, persistence, binary exploitation, reverse engineering. That's why you left last week. And now, after all this is, OK, that's fine. We need some automation, OK? So when you're attacking one computer, this is awesome, like you did, like we did. You go, SSH, exploit, and got awesome. But what if you need to keep accessing the computer many times in the future? What if you need to access tomorrow and the day after and after and after and after for a year, right? What actually if you have issues and you need to change your access? So you can put a backdoor, remember, like, oh yeah, after some privilege escalation, you do persistence, but you are gonna type and you're gonna do this by hand every time. That's very hard. So we're in a moment that if you're a pen tester, like maybe you want to be in the future, like maybe some of you are right now, accessing once is awesome, but accessing many times, it's more like an attacker. And this is one of the reasons I believe pen testing and attacking are different. Pen testing is awesome, attacking is completely different things. One of the differences is this one. An attacker needs to automate and access the computer many, many, many times. As a pen tester, you don't need that. Actually, you don't test that, so actually the defenses are not preparing for this. So what if you have hundreds of computers? What if you have thousands of computers to control? The typical botnet, IoT botnet, can go very easily to 500,000 computers. That's big ones. They have been of 12 million, but that's a limit. Usually, there are many small botnets. So imagine that you are in the underground world and you want to make a name for yourself. So you go there and you start infecting computers. By the way, if you're in the underground, how would you get computers for your botnet? What can you imagine? This is like an extra. It's not there. But imagine you are there and say, yeah, I want to have my botnet. What are you going to do? Infect your grandma's computer? I mean, maybe, but it's one, right? So how do you get new computers? Don't tell me you never thought about this. It's not only me, right? And how? USBs in the tram? Well, that's it, right? You have something. Can be a web game, can be Android game, right? Like many, many Android applications are Trojanized for this reason. Actually, that's super nice, but it's not the easiest. The easiest and the one that everybody's doing, you go to the underground and say, hi, I need 20,000 computers. And you just buy them. That's it. Just, I don't know, $20, $10, and you have access to, I don't know, SSHing or controlling 20,000 computers. This is part of the market of the underground. Somebody owns a botnet with 500,000, and they're just selling and reselling. Sometimes they're renting. I just need each of them 4 hours, and then that's it. So they don't give you complete access. They just put your malware and then remove it. It's like such a nice business. So that being said, it's not uncommon to find small botnets, people having 100,000 computers for 2 weeks. There is not even a name for that botnet. It's just there. So how would you control those? Manually executing commands, not ideal. So attacking and controlling one, that's good. We did it here. 10, yeah, tougher. If you have 100 or more, 1,000, that's something you cannot do by hand. So when it's a good idea to automate? We can automate in many scenarios. I'm pretty sure you are automating right now. And in a way, automation is the mother of later the need for having something that is running alone, and then you start scripting, and then you start hacking, and then you start programming, and at the end you start doing techniques that do stuff alone, and you end up with machine learning, for example. Machine learning is just the end of the automation. You just learn how to do this better automatically. At the end, we just want to automate. So automation is not only about attacking, right? We can do automations in benign ways, actually most of the way. For example, the IT team, that's the people working in your company, checking that computers have the latest updates, that's automation. There are Microsoft programs that you click and you say, go and check. Installing security patches, that is the Tuesday of patches, how is? The Patch Tuesday or something like that? I don't know. Where Microsoft is releasing the new updates, and then you have to update all the computers. That, of course, you cannot, right? But the issue with updating is the following. Imagine that you can go computer by computer and tell the computer to update, right? You update, and the update is taking, I don't know, 1 hour. And then you update, and then you update. This is usually not enough. Big organizations, they cannot afford this because they don't have the time. If you think about, I don't know, some government agencies in US, like the DoD, they are known to have more than 1 million computers. Imagine trying to update all of those. Yeah, like the moment you are updating, like you are spending, I don't know, 3 months updating all of those. And then you have a new update in a week. So you never have enough time to update completely everything. And that's good for you, for attackers, right? So installing security patches, defensive command and control communications between IDSs. This actually is very weird, but we have a case that it's our own intrusion detection system that we did in Stratosphere called SLEEPS. We are going to be using SLEEPS in 2-3 classes, but SLEEPS is an intrusion detection system that implements a local network peer-to-peer between the intrusion detection systems. So they actually are sharing threat intelligence. That would be a case of benign automation in a way, right? And then we have the benign but offensive ones, right? For example, like you have a red team. Remember, red team is the fancy word for pen testers. And then you have infrastructure test. You have checking for vulnerabilities automatically. It used to be NISUS or whatever. And then we're having installing benign malware. Why would you do that? Why would you go to your organization and install malware that is doing things but a little bit benign? Benign, I mean, it's not going to delete your files, right? It's going to try to copy files, for example. Well, and the answer is that you are actually monitoring if your solutions work. Do you have 2 or 3 things that you bought? Are they actually working? Are they not working, right? And that's what you do with the benign malware. If the organization is detecting the transfer or not, right? If the organization is vigilant because of the pen test, many, many, many things. For example, when you're hired to do a pen test, it's not uncommon that the defense team in the organization does not know about the pen test. Only you and the manager or the CTO. So they have no idea, and they're just like a normal day, checking something, checking TikTok or something, and then you are doing the pen test. And they want to evaluate if they are aware. So usually the CTO goes there, is like, yeah, how's going on, right? Nice day, what's up? And everyone's like, yeah, well, nothing happens, right? And he knows that an attack is going on in that moment. So there is a lot of these evaluations of the teams and the defenses. And also, of course, there is malicious automation, which means brute forcing of logins, Mirai case, for example, automated password harvesting, also you want to automate that, automated exfiltration, how do you send information out, automation of encryption of files, right, and things like that. Not always work. Automation can be badly done. So we have many, many cases that you need to be very conscious. For example, I remember when the ransomware malware started, there was a new ransomware for databases. I'm not sure if you saw these ones. Actually, did you ever, anyone here got attacked by ransomware ever? No? Nobody? Oh, wow. Internet? No? So this new ransomware, like 3 years ago, was attacking SQLite databases. And another one was attacking Redis databases. And these databases open ports, and you can connect, right? So they were going there, checking the tables, copying the tables, and then leaving a ransom note saying, I got your data, pay or you're out, right? They were not encrypting. But the story is that when they went there and you saw that your database has been completely hijacked, you have the note saying, pay, and then I will give you the data. And then they actually paid, and this was completely automated, and they gave the data, and the data was another file of another ransomware saying, I take your data, pay, and I will give you the data back. So when they were actually stealing the data, they were not checking that there was any data. So the ransomware were ransomware itself, you know, like a change. So it was not working well for that automation. Then they fix it later. So, and the one we are going to be seeing this class is the command and control for controlling multiple computers simultaneously, okay? So, questions? Automation? Reasons? No? Yes? Okay, there you go. Let's try to automate something and see how it works, okay? So we are going to start with Parallel-SSH. So Parallel-SSH is the asynchronous Parallel-SSH library that is designed for large-scale automation. It's SSH, but in parallel. So please go to your Dockers, and we are going to try to use these ones. If anyone in the internet is still waiting for the class to start, well, nothing I can do, but it should be working, okay? So the goal is we will be using Parallel-SSH to control some computers. I put here 10, but can be 20, up to you, remotely and simultaneously, okay? I like to call this like the poor man's botnet. It's like, yeah, that's all you can do for now. So, not for online students, online internet. In this class, we put several Dockers for you. So it can be a little bit confusing. You are going to have your traditional Hacker Lab Docker, okay? This is the one you got here, like now, right now. See, Hacker Lab, I'm there. But this Docker, we don't want to install every tool and library, because after each class, it's going to be growing and growing, growing stupidly. And then you're going to be using 4 gigabytes of your computer for nothing. So the decision was to create a new lab Docker for each class. So now you have one called the class 10 lab Docker in the IP 125. And most of the commands we are going to do today are going to be there, okay? So you are here, and you can SSH to that computer. I'll say SSH 172.20.125. The user is root, and the password is admin, okay? You have it there. So from this computer, the class number 10, everyone on the internet are going to be executing command. Check that the name of your computer is class 10 lab. Apart from these Dockers, on the internet, you have 3 more. 2 bots that we are going to be controlling, and 1 IRC server. For you here in CVUT, the IRC server is already installed. This is our Docker. And the bots is going to be yourself, like always. So you're going to be attackers and defenders, okay? The people on the internet, they are doing this alone in their computers. They don't have it. So first, let's create a dummy user, because we don't want to run commands as root. Who can tell me? And we have the first Mando. Who can tell me for the Mando why it's not a good idea to run any bot or server as root in your computer or any computer? Especially if you are running a bot. Mando. Do you agree with Pavel? No. Dushan? Yes, do you agree? Somebody disagrees with Dushan? No? Another idea? Yes? No? Poorly written? Yeah? Yeah? So, exactly. You can make a mistake, but I agree. Mando for you, Dushan. Woohoo! Exactly. Anything that you're running, it can be exploited or will be exploited, which means that if you're running, especially in your own Dockers, and you're going to be giving access to your Docker to your friends, which I don't trust, so instead of giving them root access, you run as a dummy user Pedro, and then if something fails, hey, you're only Pedro there. So let's create the Docker Pedro, and for this, online people, you need to log in to your bot number 1, okay? Bot number 1, that's the IP 131. You do it in your Dockers, okay? So let's do this in your Dockers. I'm gonna copy the command. I'm here in my Docker, and I'm gonna add the user Pedro. So, yeah, I already created before, it's fine. So what's going on in this command? So it's user add, as always, but we have new parameters. The first parameter is -p, which means this is the password that we are gonna assign to this user. But the password should be in the format of the etc shadow file. It's not just 1, 2, 3, 4. So for that, we actually need to use the OpenSSL command, which is a command that knows how to generate these type of hashes. So we're going to say, hey, OpenSSL, I actually want to use the subcommand passwd, so OpenSSL create passwords. -1 is going to be the type 1, which is MD5, which is horrible. I don't know why I did that, but hey. And then the line of the password. So actually, if you only execute the OpenSSL, you will have there the hash, okay? There you go. So right now, we are going to execute that in a subshell. That's the $ parentheses, subshell. And the output of this subshell is going to be used in the P parameter. OK? Got you? Then -m, we are going to create the home folder. And then Pedro is the user of Pedro. OK? So there you go. I'm going to also do this in my bot. So it's going to be 172.20.131, and it's going to be I trust in you, and admin is the user, and I'm going to do this in the Cyber Strato Lab. There you go. Now that we have this user, let's see if Parallel-SSH works. So CTU students, go to your Matrix channel and share your IP with the world, and ask your friends to be nice to you, to actually attack you, and say, hi friends, how are you? Can you please attack me? Hi, friends. This is me. This is too small for you, but I can do something like that. This is me. Attack me, please. There you go. Oh, I lost connectivity with something. Who knows? Do you see that? Or I'm blocked for some reason unknown? This is Cheveute students. You see it? Perfect, there you go. So I will give you a minute, get your IP address of the Cheveute students, and share in your matrix, and then pick up a friend. Is it streaming good? Perfect. Internet people, you don't need to do that because you're already in your bot, okay? Can I make you bigger? Oh, I can make you bigger. Aha, that's nice. But I don't have connectivity, so I don't see you, you don't see me, I don't know. For instance, did you put something in the channel? I see nothing. Is there stuff? Okay, I lost my connection to the server. I don't know why. Hi, are you the winner? No? How do you know he's not the winner? Aha. I don't know. Maybe she wants to take the prize, you know. Nothing. We'll tell you later. If you have an IP of your friend, pick it up, and I will pick randomly because I don't see your IP addresses. So we are going to be using the command called Parallel-SSH. Or you and internet, okay? We are going to be using capital A, which means please ask for a password. We are going to be using -H, which is the host to connect to. It can be a list, not we are going to be here putting the IP of your friend or bot. Then -L is for the user. -O is for options, and the options we are going to be using is strict host key checking no. So that means accept the SSH host keys from remote servers and those not in the known host list. So, do you know what that means? Was it too cryptic, too fast? What does it mean, this one? We did several times, so I know you use it already. What does it mean? Yeah. Yeah. Very well. Very, very well. Okay, you deserve a mando. There you go. Are you ready for the mando? 1, 2. Look at that. We are getting so good, people. I think I was born for this. And we don't want that because if the Parallel-SSH automation is going to stop to tell you, do you trust this server? Well, it's not going to be automated anymore. And then -I show the output inline for each server, right? So you can see what's going on. And the pwd is the print working directory, actually the command we want to execute. Okay, so go and try this and tell me if it works. I'm going to do this in my computer, and I'm going to just pick up some random IPs because I cannot see you people. 034. And it's going to ask for the password. Which is the password? This is Pedro, right? Remember, because the people just created this user. So all of the users have the same password. And let me see if 34 is working. Oh, permission denied. So 34 is not there. 43. Or somebody can actually give me their IP too, right? Oh, Juan Pedro, there you go. Success, right? You should see the success in there. If you do here, so this is also the user Pedro in the bot. And then in the internet, to run the Parallel-SSH, you get out of the bot, okay? And you do this in the class lab. So this goes, there you go, in the class lab. I will just put in here class 10 Docker, right? And you do the same. But on the internet, you know already the IP of your bot, right? So the IP of the bot is going to be, oh, what happened there? I think that my terminal is a little bit broken. It's fine. I can do it anyway. And it's going to be 172.20.0.131, I believe. The password is going to be the same. So did it work for you people? Yes? Perfect. First automation. Look at that. Success. Juan Pedro. So now that we are having this working and we confirm, let's try to solve some of the limitations, because that didn't feel like a lot as an automation, right? So the first one is I don't want to put the password. Like, that's lame and that's stupid. So we are going to be using a program called SSH pass. And SSH pass actually takes the password, in this case like -p, and then it's the same command as before. So I'm going to be copying this one. Please try to see if SSH pass actually works for you. There you go, 131. No, not you. Yes, but you. 172.20.0.131. And should work without putting a password. Woo! Success. What about you? And you were 44, I think, right? 172.20.0.44 without password. Success. So it worked? Yes? Very nice. Now that we are not putting the password anymore, we don't want that banner that is horrible and long and this. So we are going to be doing the option, capital O, log level error, which means it's not going to be printing information things, right? So we do that one, and then we put the IP again. I'm going to be using 172.20.0.44. And there you go, no more banner. Okay? Ready for you? I will give you some seconds. Yes? Internet? I cannot check the comments, so if you can be aware of the comments on... Thank you very much, people. Are there any questions in Matrix? No? Nothing? Okay, so we don't want to scroll our terminal to see the results, right? Because we can miss things, the terminals can go up. And for that, we will tell Parallel-SSH to store the output in a file, okay? So we are gonna remove the I option because we don't want that anymore. And we are gonna just execute this without that. And if you, oh, sorry, and also we are gonna be adding the dash small o PSSH output, okay? That's the one saying, don't be interactive, just store in a file. And the file, or the output, is gonna be called PSSH output. That's not a magic name, that's the name of the folder, okay? The name of the folder is gonna be PSSH output. So if you execute that, 172.20.044, now you have success only, but you don't have the result. So to see the results, you have to list all the files in the folder PSSH output, and then you say, oh yeah, actually I have stuff. Well, actually I have stuff from before, so I'm gonna delete everything there, and then I will run again, and then I will see, oh, PSSH output, right? Are you there? Yes. And there is a file for each computer, so that's a file, okay? So if you just see the content of that file, you will see the output of the command, okay? So tell me if that worked for you. I'm gonna do the same in the Stratocyber lab. Perfect. Yeah, this one. Oh, it's getting tough. Oh, it's getting tough. So it's going to be 172.20.0.131. There you go, success, and then PSSH output, there is a file, and home Pedro. Okay? Everyone? Yes? Working so far? Perfect.
An online question, maybe?
Yeah.
I don't quite understand what the automation aspect of these commands is. We're still executing one command manually and getting one result per execution.
True story. So he's saying, I don't understand how this is automation. Well, so far, not so much, right? Because we're just replacing the SSH you are doing with yours. So far, you didn't gain a lot. We are preparing to run this more and more and more, okay? So right now, we are actually about to get into how to make it in more hosts automatically. But this is one of the procedures that you can do for one host, and when you check that it's working, you can do for 100 if you want. So in 1 minute, we are going to be there. Let's connect to many hosts automatically with Parallel-SSH. So for this, we need not want to manually list all the hosts, right? That's maybe too much. So for CTU students, what we are going to be doing is that we are going to be creating some random amount of hosts that are here in the network, okay? So that command there, that for, is going to generate a random list of hosts that are in the CVUT network. If you are in the Stratocyber Lab online, you know the 2 IP addresses of your host, so you just put them in the file. What we want is to create a file with all the IP addresses that you want to control, okay? So if you do this for command, and you press enter, you will see that many IPs have been generated for you. And if you do again, and again, they're gonna be randomized, okay? So we're just randomly choosing 10 computers around you. Can be 20, 30, let's see. So how does it work? We are doing a for in bash, and the IP is the name of the variable here, IP, and this variable is gonna change values following this subshell. And this subshell in bash, it's the command sec, and the command sec is a command that generates a sequence. In this case, a sequence between 1 and 10. That's the command. And then all these sequences are got into the IP variable, and this IP variable is going to be taken into account when we are doing the printf, and it's like printing the IP address 172.20.0d, and then it's including a digit here, and using the random variable of the system to actually generate up to the 49 IP address. So this is randomly choosing a number and then replacing the D here. The number 1 to 10 is not for the IP, okay? It's just a counter. It's just to do this 10 times, okay? That's the only reason of the 1 to 10. And then we are using T. Do you remember T? The command to split, like in a T, in the standard output and in a file, okay? Is going both directions. So that means that you should have a file called PSSH host where you put the host you want to control. And in the case of the Stratosphere Cyberlab, you just run this echo, and then you check that you have the 2 files correctly, okay? Because you only have 2 hosts. By the way, you can spawn 20 hosts in your Stratos Cyberlab if you want, right? It's up to you. Now that you check, let's finally use it. So the command is going to be the same with the pass, Parallel-SSH, but now we use small h to identify the file name. The user is Pedro, the same, everything, and the command is going to be who am I, okay? And we are going to be, I'm not sure if, did we talk about this type of redirections? Do you know what that means, that command there? The to greater than /dev? Who can tell me? Very well. That means, if you remember, every process in Linux, Unix, has by default 3 pipes, let's call them 3 types of output assigned. That is the standard input, right? It's a pipe to get the information in the process. Standard output, usually tied to the display, right? And standard error, where the errors are going. So the programs know that if there is an error, they should put it inside the file standard error, and if they just have an output, should go to standard output. So the IDs of these 3 channels are 0 for standard input, 1 for standard output, and 2 for standard error. So that means, hey, take the file, take the pipe of the standard errors, that it's 2, and then redirect, greater than redirect, into the file called devnull, which is nothing. It's like a special file that whatever you put in there is destroyed. So that means exactly, do not print error logs to me, okay? So if you do that in your Docker, you will see, for example, I found 2 computers that it was a success, and in the others, probably they don't have this running because it was random generator, remember, okay? And the same I can do here, the same command, and actually I only have 2 IPs, and I expect both to be successful. Do you know why the second failed in there? So the first one in the Stratos Cyberlab worked, and the second did not. Did you notice why? If you remember when I was typing, I created a user Pedro only in the bot number 1. I never created a user Pedro in the bot number 2. And this is using user Pedro to log in. So there is no user Pedro in the bot number 2. Online, if you want both bots to be controlled, go to the bot number 2 and create the user Pedro, okay? So now that we have this part of the automation, now we finally execute a command in 10 computers, and you can do 100, no issue. So if you have a command that you want to do in 100 computers, you can use Parallel-SSH, and you have automations for all of them. It's very simple, it's not crazy complex, and it's not crazy malicious. It's just how many people automate things. So let's do some stuff with automation. For example, you can list the processes, right? Look at this. So the command is psuafx. If you do this, and you run again, it's going to connect to everything, and then look at that, much, much faster. And then you can see what's going on in the output, because you have many computers, and see that you have the outputs there for you. So you know exactly what's happening. Okay? Questions? No? Yes? Was it clear? Internet questions? Which? Yes, here there is nothing telling you because all the lines are together, but if you do this command that I pass over, the grep, if you remember, is searching patterns inside files, okay? So here I'm saying, hey grep, I want you to search for the empty, which means it's gonna match everything in every file that is in this folder. But the capital H specifically tells grep to print the file name. So if you do that now, and you do the same, you're gonna have the information, and then you're gonna have, I want to go to the first one. Okay, it's the same. You're gonna have the information, but the first part of the line is gonna be which IP did it, right? So that's much better. Oh yeah, that was like the 33. Where is 33? And this is gonna be in the 46, right? Okay? Questions? More questions? No? There you go. So yeah, remember, because part of the assignment is going to be controlling million computers. No, I'm joking. But that can be nice, right? That can be nice. So example commands to SSH. One is the processes. What about this one? Look at this. We are getting complex. Our commands are getting like 3-4 lines of text, right? This is kind of a thing. So what's going on in here? The same as before, but now the command is going to be a screen command. Remember, screen is like Tmax, actually creating virtual terminal. So this is going to create a virtual terminal that is going to be in the background, that is like back, and then it's going to be, this is a new, like start, and it's going to be called automation screen, that's the name, and then it's going to execute bash, passing a command that is a while true, do, output the date, and then sleep 1 minute, and then done. But the amount of things, we are passing commands in commands in commands. So any small error that you do here in the single quotes or the double quotes is going to be critical. That's why you should pay attention that sometimes it's using single quotes. So the single quotes is for the command inside the screen, and the double quotes is for actually the command of, there you go, the Parallel-SSH. Okay? So be careful when you are doing your own. So there you go. Oh, shoot. I'm going to copy this. I'm going to execute. Failure, success. There you go. And then if I just see the output, well, nothing, no output here because there is nothing the screen does, okay? Now, this is going to be running, and actually, I will check if somebody did a screen for me. Oh, wow, I have like many screens in me. So you can see that somebody was very successfully doing something there, including my, this is fine. So I'm very relaxed that that's fine, so I'm not going to kill it. This is actually dangerous because we don't know what's going on. So when you want to kill things, you can use pkill. Pkill, the process kill, is a command to kill, well, processes. So you can copy this, and then you execute, and what you are doing is just stopping the screens, okay? So I'm going to check if somebody's stopping my screens. Oh, look at that. No more screens for me. Did you notice what was the problem with that pkill? Can you tell me? Life, no, with security. I mean, what was the problem doing that pkill? What did it kill? Which one? All of them. I mean, I could have my own screens, right? So this was sloppy. If that's, as an attacker, you want to stop your screens and you kill all the screens, I will notice, right? So that was a mistake. Also remember that I wanted to say, and I forgot, if you are online, the screen command is not going to be in your bots. So if you do 172.20.131, you log in, you do admin, and you do screen, it's not going to be there. So apt install screen is gonna be make it happen, okay? You don't have to have it, but if you want this command to run, then I'm gonna get out into my class lab, and now if I do this screen, it will be different, okay? There you go, succeed. See, if not, it's gonna say, hey, no, don't, it didn't work, okay? So, oh yeah, you have it here, sorry. Yeah, you have a screen, now you have it. So what about running a reverse shell? That is, I think that this is fine that somebody was doing on me. So it's the same, but now we are doing a screen. Why I'm doing a screen here? Do you know? Can somebody tell me why the command I'm doing is a screen or a tmax or something? Why I'm not just doing the encode? The shell is killed. So the shell ends, right? So you have here to have something in the background and then do the encode and then open this. And can you tell me, anybody, what's the encode doing? Do you remember those parameters? The L, the K, and the C? But where is the reverse shell? What is the K and the C? So the L is the port. What is the C? The command, right? So that's the bin bash. And what is the K? If you remember, it was be a broker, which means an intermediary. So this is when you connect to encode, and if you disconnect, encode dies. Encode is like, well, that's it, bye-bye. So if you have one shot opportunity and executing a command, and you do an encode, and you didn't put the -K, you only connect once, right? And that's probably very, very challenging. So -K is gonna keep it open, so we can try that one. Now I'm opening encodes in many computers. Let's see if I have mine. Oh, that's it. Somebody's having a reverse shell on me. I like how we have reverse shells open to our people around and friends, and we are super relaxed with this one. Usually we are gonna freaking out, but that's it. Yes, and also, I think that encode is or should be already installed in the bots. So let me check. Admin encode. Yo, encode is there, so this should work. So if I do the same command, no, not you, but this command in the Cyber Lab, it should work. Perfect, there you go. So now you should kill again, because having a backdoor there open all the time maybe is not a good idea. So we want to kill all the backdoors. So this is gonna stop them, and also I'm gonna stop them in the Cyber Lab, okay? Again, pay attention that you are killing every encode. So how would you actually solve that problem? How would you not kill every encode, but only your encode? That's a good one, right? So first search the ID of the process that you own, but be careful that the user Pedro may have other encodes. So you have to search for yours, and then you can kill those, okay? You can do this in one-liner command, but just pay attention in that one. Can I ask you people if you can tell me when to do the break, because I'm losing a little bit the timing. Is now time? In 5. Okay. So in 5, tell me to 30 when to do it. So what are the limitations of this type of automation? Well, we managed to overcome some of the limitations of Parallel-SSH, right? But there are many that we didn't solve, all right? For example, we still require previous SSH access. We still have hard to deal with access errors, right? Like working, not working, whatever. One of the most important issues is that we have an unilateral communication. So we send an instructions, and then we retrieve results, and then we need to check. So a lot of manual stuff still happening. Parallel-SSH is good, but it's kind of a first level. Of course, it's easy to block, and there is no information about is the connection down, right? Is it blocked or stuff like that? And there is no recovery mechanism. So yeah, it's good, but we can do much better, right? So okay, automation example with Ansible. Okay, now, yes, like Ondra was saying, probably it's a good moment to do and before jumping into the Ansible. So, any questions so far? Good question. Yes, thank you very much. If it's possible to connect to different computers with different users and different passwords. Yes, it is, but it's very hard to configure. And I will be a little bit scared because the errors are very easy to make. This is exactly, actually, you know what? Right now, I'm going to add it right here. Like having many different users and passwords for host is not easy. I mean, it's possible, but oh my, right? Like not only the adding, but also the maintenance. Imagine when those users change, when the passwords change, you have to go manually. And again, we want to avoid manually. So we are in a situation that we need something better. And that better is going to be Ansible. Okay, so let's make a stop right now. And we are back in 10 minutes, right? So at 3:36, we are back. Internet, 10 minutes, and we are back. Go get some snacks, people. Okay, let's continue, people. Internet, we are back. Internet, get out of wherever you are, from the kitchen, leave the cookies. So, before starting, we have the winner. We have the first prize. So what was the name again? So we confirm. Wait for it. Okay, we have to trust you in this one, I think. Okay. Please come here. We have the Eco Party, one of the CTF badges. Bravo. There you go. Congratulations. Hope you enjoy it. Tell us how it works. I have no idea. I asked him to please pick it up in the interval, but he didn't want. He just wanted to. No, I'm joking. That was me. So congratulations again. Very nice that we have. And and thank you for the anonymous donor online. So automation example with Ansible. So Ansible is a software. Who is using Ansible here? Ansible. There you go. Lucas? No. Nobody else? Yes? Yeah. So Ansible is crazy awesome, people. If you're not using it for your daily task, if you have more than one server, it's like the way to go. Software suite to perform IT automation of a multiple or multitude of systems simultaneously, also known as infrastructure as a service, or, well, not Ansible, but the concept of managing a huge amount of computers and in an infrastructure. It's this infrastructure as a service, where you just deploy things and you create instances in Amazon or whatever, Google Cloud, and then you took down and install things, uninstall, configure. Ansible is going to help you there. So the feature I like the most in Ansible is that it's agentless. So you don't have to install anything in there. It's always using SSH, which is awesome. I don't want to run stuff in my servers. Just connect like I do and do whatever. So in that sense, it's a similar strategy as Parallel-SSH, but much better. So it's idempotent, and that means that whatever task, right, or the same task can be repeated many times, and it's guaranteeing that the state will be the same. So if you go and you say, I want to create a user, it's going to create users. If you press enter again, and it's going to execute the same command, you guarantee that what you want is at the end, all the computers having one user. So you're not creating 2 users or 3 or 4 because you are pressing enter many times. So it's keeping the state and telling you that this is idempotent. And idempotent, as you know, not omnipotent, if you know what I'm talking about, just in case. So let's Ansible a little here, okay? Ansible is installed in all your Dockers. If it's not, you can do apt install -y Ansible. It's very simple. You can go and get it. So let's first create a folder for the playbooks. I'm not sure if you are familiar with the concept of the playbooks, but a playbook, okay, who knows what is a playbook? There you go. Lucas was faster, I'm sorry, go. Exactly, and it's all these tasks and conditions, right? So it's like a set of rules and when to execute what and what you want at the end. And when you have these playbooks, you can deploy it. And I'm saying this because in many cybersecurity products, when you have the CM, when you have the people looking at the cybersecurity incidents, they also have playbooks, which is what to do when you find this situation. So it's like, oh, when you find this, open the playbook and you run. And the playbook is like connecting, disable accounts, changing passwords, telling somebody, telling the police, sending emails. So all the things to do are defined in a playbook, and which is probably the best tools that defenders have in CMs. It's like crazy, crazy good because they can customize their decisions, okay? So a playbook is a very interesting concept in cybersecurity and IT both. So after that, please get into the folder root Ansible. I'm gonna create both. So do you know what the -p does in mkdir? Mkdir? No? So -p creates not only the final directory, but also the ones in the middle that you're putting, okay? That's why root Ansible exists now. So now that you have that one, we need to create a file with all the computers that you need to analyze or check or modify. So this is something that it's not completely easy to avoid because we are using tools designed for the defenders. Parallel-SSH, Ansible. So as a defender, you should know your infrastructure. Later today, we are going to see examples of how do you do when you do not know the IP of your computers, like malware. In this case, we do know. So if you're online, you know the IPs of your two bots, 131 and 132. If you are a CTU student, let's put some information here. Right now, we don't care so much. I put here some IPs, but just be free and change these IPs to whatever of your friends you want. So we need to create a file called hosts. Oh, I already have something here, so I'm gonna recreate. Copy paste the content. There you go. I will just, I will leave it like that to see. Oh, I will change 44 because I remember 44 was working. So that's it, okay? And if you are in the Strato Cyber Lab, we are going to be creating these two. So the line that says bots, this is kind of the name of the group. So later on, with Ansible, we can refer to this group directly, okay? Now we are a little bit more complex. So after that, we are going to be executing Ansible. If it fails because of SCP issues or SFTP issues, you may need this line, but we are not going to do it because you should not need it in our setup. This is mostly if you do it later at home. So, what's going on with this command? Oof. This command is, first, we are setting a variable. And the variable we are setting is an environmental variable called lcall. And this lcall, we are putting the value c.utf8. And why we are doing that? Well, if you remember, when you are setting a variable before a command, so the command is SSH pass, but when you put a variable before, this is setting the variable value for this specific command. So it's not changing the variable for the whole session of bash, it's only for this command, okay? It's a very useful way of putting variable values before the commands. And this one in particular, it's setting an environmental variable that controls the locale settings, okay? And the locale settings usually are the differentiations between the languages, regional preferences like character encoding, sorting rules, date formats. As you know, some countries use the comma for the thousands or the dot for the thousands. All these differences are managed by the locale. So what we are saying here is like, okay, all the difference in the regions, LC all, we need to set to C, that is the POSIX standard, UTF-8. UTF-8 is a character encoding format which actually gets out of your traditional ASCII and includes non-English characters. For example, Spanish characters like ñ, stuff like that, or Czech characters. So that's why we need this one, because if not, if the locales of the source and destination computer are different, there can be many problems, right? So here we are saying, hey, set this variable, and then the command is going to be SSH pass as before, because we need to give the password, and then Ansible is the command, and in Ansible, I'm going to go down, we are going to be using bots for defining the group of hosts that we are going to connect, then -m indicates that we are going to be using a built-in module, because Ansible has many modules. And actually, if you use Ansible in your work, you will find online Ansible modules for everything, like for connecting to Discord, Ansible for Slack, Ansible for Minecraft servers, whatever. So this is, no, I'm going to use a built-in module, and the module is called ping. You can imagine that this module is connecting to one of the hosts and doing a ping. But this is not your ICMP packet ping. This is an Ansible ping. This is inside the connection of Ansible saying, hey, are you there? And say, yeah, I'm here, okay? So this will work even if ICMP it's not working, okay? Then we are gonna assign as in the inventory to use. So the file with the list of hosts is called hosts. Maybe not the best name. Host is a file name there. If you remember, we just created that file. And then the user we are going to be using is Pedro. And that is the user Ansible will use. And then Ansible is going to ask the password. Okay? Ask the password. And the password is going to come from the SSH pass. Okay? So this SSH pass with the password is going to answer to this ask pass. Okay? And similar as before, we need to tell Ansible, just ignore if you don't know the host. So that last command, this E there, saying Ansible SSH common arguments, and then the option for SSH is -O, strict host key checking, the same we did before. Okay? Ooh, that is taking some time to explain the commands. We are going to try this one. I'm going to try from the CTU Docker. And we have some things. Oh, some successes. There you go. And then a lot of errors. That's good. It means a lot of the host output there don't work, and some of them do work. Okay? So do you have these issues too? Some reds and some succeed in the middle. 68 for me is working. You can see the pong there. Does it work? No? Yes. And we run from the... There you go. In the case of the StratoCyberLab, you should have at least one success in the bot 1 and a failure in bot 2, okay, online. And if you have questions, people, just ask, okay? Everyone fine? No lost people? Okay, let's continue them. Now, after doing all this, let's run something a little bit more complex in here. So we are going to be running again a process with screen, so you can have the same feeling as before. But for this, we are going to be creating our first playbook, okay? Playbooks. So the playbooks we are going to be storing in root Ansible playbooks, and this one is called run screen background.yaml, if you know the YAML format. So you just go to that file and you press, oh, okay, I have something before. Enter, and then I'm going to be copying the content. There you go. And the same I'm going to be doing in the StratoCyberLab. Okay, you go there, I have nothing, and then you just completely copy the content. Okay, so there you go. We have a first playbook. which name is run the command in screen session on all hosts, bot hosts. This is our description. And then which host we are going to be using? Well, the group that is called bots. If you remember the file we created, was a group called bots. And which are the tasks? Well, we have a name for the task, run command inside screen session, and then it's going to be a shell, and it's going to be a screen -d, the same as before. Automation screen, bash, while true, do, date, something, something. Okay? I'm going to save this. I'm going to save this. And now that we have this, we can run it. So to run, same as before, the locale, SSH pass, the password, Ansible playbook, now it's called. If you pay attention, I will mark this, but the command is called Ansible playbook, okay? This is the new tool. And then it's going to be using the host file, user Pedro, and specifically we are going to be running this playbook. You can run 20,000, right? The Ansible is crazy complex. You can have playbooks, running playbooks, stuff like that. And then it's going to ask the password, and again, it's not going to check the host. So if we do that, and we press enter, we will have a lot of greens, and well, a lot of reds and some greens. See there, we have an OK, 2 OK, 3 OKs. Ah, look at that. That's one of the beauties of Ansible. We have a summary table with what happened. Every computer, if it was OK or not, if it changed the state or didn't change the state, if it was reachable or unreachable, if it failed, skip, rescue, ignore, and others. Beautiful summary, okay? Now we have much better control of what happened. And remember I was telling you that it was idempotent, which means that some hosts may not change after this. Some may do. That's why the ones they are changed are marked in yellow, okay? Did it work for you, Ansible, everybody? Yes? Perfect. Perfect. There you go, there you go. I'm running in the Stratos CyberLab. One run, another one should not. One okay, the other one not. So, after running Ansible, now we are much better out with our automation. Let's try other commands. So now that we have the screen, let's try again to kill it. So try to see if you can kill these screens. Actually, I will first check if I have the screens. I have no screens. Nobody execute this on me. What? I'm super reachable. 02. Maybe somebody mess with my... Pedro is there. Pedro, where are you, Pedro? I'm gonna... Okay, I will put the... Try again. I will put my password again in Pedro. Maybe somebody changed the password of Pedro because, you know, these attackers. Okay, what about now? Oh, I have SSH Pedro, 2 SSH Pedros. No? That is weird. If I do a sudo Pedro, do I have... Oh, you don't have screen as Pedro. Oh, yeah, you do have. Yeah, no problem. That is weird. Okay, I can see you there. And what, did you have an error or something? No. Any error? No? What does it say? I'm too secure. So it works the command, other docs are working, not mine. Wow, I have no idea why. Maybe somebody changed something, I don't know. I should maybe delete the user? I have no issue in my side. Okay, so then you kill the screens, okay, as we did before. Please kill, because if not, we will have 1,000 screens all over the place. And there you go, this one, right? Yes. And this is killing the screens. And now we can check the process running also with Ansible. So we have the command for that. I'm going to try to do this in the Stratos CyberLab. There you go. And you can have the output there. Can you make this happen? Did you see it? Does it work? The processes? One, two, three. Yes? No? Maybe? From time to time? Yes? Okay, something work. And did it work, this one, the process listing in me? Nothing. Okay, there you go. Who knows why? And yeah, we have some screen there if you want to see that. So now let's stop with Ansible. If you are a CTU student, please clean your Docker because people. So del user Pedro, there you go. So Pedro we are not using anymore. Delete the home of Pedro too, just in case. Check your running processes because people is nasty. We have some, look at these, 3 Ansibles there running. Yeah, I'm not sure what I can do with that. And then we have a screen, this one, that is my backdoor. So there you go. I'm gonna kill the backdoor with kill. And oh, this like nasty one. So kill. Oh, that's 9. And then what else? Yeah, how much stuff going on? Somebody's there. Pedro is still logging in. Okay, Pedro, you can stay for now. Then I will kill you. I will kill one of you, just to kill you. There you go. Oh, it's already out. Ah, you get scared, Pedro. Take that, Pedro. Oh, there you go. No more Pedros anymore. So when you are sure that nothing more is in your computer and you kill everything that needs to be killed, we can be relaxed, okay? I will give you 10 seconds if you need. In the Strato Cyber Lab, you don't need to do this because you are alone, most probably. Be sure you have nothing extra. No nasty things. You can ask questions also in the meantime. Nothing? First, I must say, I don't know because I never ran a botnet, just in case of the recording, but I can imagine that. Now, usually there is no such a thing on purpose on capping the, nobody is putting that. Usually they know that the computers are gonna power off, computers are going to start the next day. So you have a lot of computers disappearing, a lot of new infections happening. So this is kind of a continuous thing, right? Continuously infecting. If you stop infecting, eventually they will die down, right? So you don't usually have the problem of too many computers. You may have the problem of too many connections to some of the services which are doing a DOS without knowing. But I never knew a botnet that actually says, oh yeah, don't do that, stuff like that, right? Some botnets try not to infect twice the same computer, so they are checking if there are other malwares, getting the other malware out, and then if they're there, they don't infect, but this is all they do, right? Yeah. And if you remember the first worm ever, the Morris Jr. worm in the 86, that was the first mistake of the worm, right? I read that he said that he never thought that the worm was going to be so successful, so he never checked that the computer was already infected. So actually the worm was infecting the same computer again and again and again. So it's computing from A to B and to B to A to B to B to B, and then that was the DOS. That was taking out the communication because it was like 100,000 processes. So that was kind of a mistake and what eventually led to discovering it, right? Okay, so if you kill everything, we can jump into the next topic, that is command and control channel. So what is a command and control channel? I have the last Mando here. So this answer should be Mando worthy. Ah, yeah. would be very nice if I say, what is the question, right? I was just thinking about the Mando wording. So the question is, what's a command and control channel? Mando wording, because this is the way. What's the command and control channel? What? Oh. Yeah, go. Okay, so a channel, if you extrapolate, I want dictionary definition, if there is such a thing.
It's a communication channel between the botnet and the botmaster. And the master is giving orders to the botnet through the communication, some kind of communication channel. It can be through internet, the bots can connect to some website and get their orders from there, or some other type of communication.
Okay, do you agree? Somebody disagrees with the definition? No? Yes? Somebody has something more? Nothing? I like it. I think it's good. There are some features that I want to see, but basically, I'm going to repeat a little bit what you said, but it's a communication channel between the server, right, you said, or the master or something like that, and then some bots or control computers, and you're sending commands, right, from the controller to the bot's control. And what else you said? There is like sending back.
Like I gave an example with
Yeah.
the bots can actually connect to some kind of website.
For example, bot connecting to a website, SSH, downloading something. Very well. I like it. Mando wording. Where you go? We can do this. Yes, 3 out of 3. Oh my. I think it's a Mando that is very balanced, so it's like streamlining. So that means that you have something that you want to control and you need to control it. You need a server, but also you need a channel. So there are two pieces, okay? This mechanism can vary a lot. So what do you need to have a command and control channel? And what do you need to have a command and control server? So yes, it's a way to connect to the command and control server, right? Some computer or computers that are out there. You need to receive orders and you need to send answers back, okay? So these are the traditional mechanisms that we call, especially in malware. So important is that you should not confuse the connections to download the malware with the command and controls. These are two different infrastructures. Actually, if you see botnet infrastructure, the command and control channels are very complex. They have like first layer of infected bots, and then second layer of command and control proxies, and then third layer of command and control database background, and then the bot master. So it's like a huge network, right? It's very complex. Part of this infrastructure includes how the infected computers gets the new malware. Where do you put the new malware? You cannot put it in many places. It's being blocked. So these places where the malware is put usually are compromised computers, domains from websites of the internet, and they only last a couple of hours, 2-3 hours, 3 hours, 4 hours, that's it, and they are taken down. So those are not command and control servers or channels. Those are just places where you can download the malware, okay? And if you want to read a little bit more about command and control, that PDF is very good about it and crazy detail about how they work, okay? So let's gonna focus on network-based command and control, because you can have many that are not network-based. So the command and control is usually started by the big team, and why is that? Why the big team is the one starting the command and control channel and not the server? Exactly. And usually not even easier, but impossible, right? So imagine that right now you go to the internet and then you scan the internet and then you find computers. Most computers have the ports closed, right? It's a computer, one IP address, going to a company, something like that. Even if it's some IoT device on the street, because I'm not sure if you realize, but the majority of the things that are electronic on the street, from lights in the street for cars to controllers of boats to whatever weather station, they're connecting to the internet, people, with some 3G, 4G SIM, which means they have an IP address, which means you can ping them and connect to them right now. So what's stopping you from getting in? Well, I hope a good password or something, but this is a very weird hope. So these computers, especially if you are, for example, coming into the university, you have firewalls, some security precautions, so you cannot get in. But the computers in the university, like you right now, usually you can get out without any filters. So the victim, that's people, for example, inside the university, connect to the command and control that is outside, okay? Usually, when you are controlling your botnet, you want to give orders, but you want to use it. So you want the orders to arrive very fast. You don't want to be, you don't want to be waiting for a day to give an order. So that means that this command and control channel should be updated very fast. And also, you want to know if the bots are up or down very fast. So if somebody powers off a computer, you want to know very fast. You don't want to give an order, maybe send a password list to a computer that is off. So that's what we call the heartbeat. The heartbeat is special packets, special communication in the command and control channel saying, hey, are you there? Yeah. Are you there? You. Are you there? You. Are you there? Evidently not, right? Timeout, and that's it. So the heartbeat is one of the features of a command and control channel, okay? Usually goes from seconds to a minute because you don't want to wait more than that. Why would you wait more than a minute? Imagine you are creating your own command and control channel that, by the way, you will have to do, and then you are creating the command and control channel and you say, how often should I check? And then, why would you do more than a minute? Or more than 10, like in here. Internet? Why would you do, yeah. To be quiet, that's good, right? Because if you are sending a lot, the people is checking the traffic a lot, and then they will see it a lot, and you don't want this. So if you want to be very sneaky, you say, yeah, every 5 minutes, every 10. Can you wait? Are you super desperate for these computers? Maybe you can wait an hour, and then you just give commands like, okay, whenever you're up, I want you to send spam, but no rush. That means that it's going to be very hard to detect you, very hard. Usually the people don't care about this because they are not being blocked so easily, but yeah. In the rare cases we saw some malware doing this once a week or once every 20 days. So that was crazy because actually we execute the malware in the laboratory and then you just stay there and you wait, but you don't know how much to wait. So you just keep it for 6-7 months running, and then you find out that, oh, it's connecting every 2 weeks, right? That it was very, very difficult to find. So then you want to control various computers at the same time, right? So you have many victims, and you can see them doing the same command and control connections, right? So that's another of the feature. The third feature is synchronicity, because the power of a botnet, it's in the numbers. It's in the number of hosts. So if I have a botnet, I want to use it, and I want to do a, I don't know, send spam, DOS, ransomware, installing malware. I want to rent it. I want to move it. So the power is in give an order and have all the computers do that simultaneously. So it's not you do it now and you do it in a week. I want at the same time. That's why the DOS works, because we attack at the same time. So your command and control channels should kind of balance this, and you should be aware that all the computers are executed at the same time. For example, be careful with the time zone. If you are saying execute this at 2 p.m., you are going to have issues with the time zones. So usually this is not a good strategy. You just say, okay, just do it now. I'm going to tell you when, and then I will send, and you just have so milliseconds of delay, right? But some malware had issues with the time zone. So then you want it encrypted, so you have issues there. Nobody's watching what you are doing, right? And also because the majority of the traffic is encrypted, especially if you use TLS. Obfuscated, yeah. Obfuscation is good. You can, do like steganography with images, but this is very, very, very weird. Like usually you are sending, I don't know, bits or bytes, and that's not enough. So some malware is doing obfuscation, like trying to pass us, I don't know, a connection to YouTube, but at the end is very, very small amount of data, okay? So, one thing is the command and control protocol, right? Used to actually transfer orders and data. And another thing is how to find the command and control server on the internet to start the command and control protocol, right? So sometimes you have different protocols that can be used, like HTTP or TLS or SMTP, right? But it's not the same. How do you find that command and control server? How do you connect for the first time? So imagine that you are a botnet or you are a bot and you need to connect for the first time. That one is different from the regular command and controls you're going to have later. So we are going to see some examples now. So let's do the thought exercise. You are creating a botnet. Internet, you are creating a botnet. Maybe you did create a botnet. How would you control it? So you're at home programming in Prolog or whatever you use, and then you say, yeah, that's my malware, right? And then you compile or whatever you do with Prolog, and then that's it, you have it. And then you put in USBs and you put it in the street, I don't know, or you send by email or whatever. So imagine the malware is out, and the people will execute this malware. I will put it here, press enter, execute the malware. How will the malware find you? How will the malware find your command and control server? What can you tell me? Give me ideas. Give me ideas. IP address, right? So you say, okay, malware, look, I am in 1111. When you wake up, go there, try to find some port open. I have a netcat there, and then that's it, okay? That's one. An IP address directly on the malware. What's bad about this one? It's traceable, so the people will, well, you did the reverse in class. You will open the malware, and they will see 1111. Even if it's encrypted, 11. So if I am security analyst, I would say, yeah, 1111. I would just block that, and that's it. You're out, okay? Very easy to block. Of course, very easy to do. So, second idea, a domain, right? Because you're smart. So, no IP addresses. We put superattacker.io or something. So now the malware gets up, resolves this domain. Now I can put a new IP every day if I want, or I can change the IPs whenever I want. So you cannot block my IP anymore because there is no one, there are many. But we have the same issue with the domain. You reverse engineer, you check the code, and then you find the domain there. And then what do you do when you find the domain in a malware? You block it. Or like what happened in the past, you register the domain if the domain doesn't exist, right? Because if it doesn't exist, probably you can control the botnet. So that's a good idea, but it's going to be blocked, very easy. So that's not enough. New ideas? What is a secret public channel? Okay. A friend told you about this, right? A friend told you about this. It's not your botnet. A friend of a friend. No, I'm joking. So, but how do you find the public channel? IP or domain? What is a service? IP or domain, right? You end up on IP or domain. Whatever is Discord. Yeah. Okay, got you. So what you're saying is like, I will put an IP or a domain, but since many other people is using it, you are not easily going to block me because then you're going to block whatever. That. I like it. Oh, such good ideas there, right? Theoretical ideas. No. I like it. So you are saying it's like, hey, I'm going to connect to something like Discord or something like that. And then once I have the communication, I'm going to download something, images, text, whatever. And then I'm going to do something. That's a very good idea. The only problem with that, and many malware is doing this, Discord, YouTube, Dropbox, like all over the place. Actually, it's very successful until the moment that organization finds out, right? So the problem with Twitter, for example, it used to be, well, now it's another problem, but it used to be that the people were creating bots in Twitter, and they were working, but Twitter used to have a very nice group of people taking them down. So the lifespan was something like 6 hours or 4 hours. And then you lost the botnet. And losing 250,000 computers is tough, right? You don't do this every week. So you have to be very sure that Discord is not going to block it, or Microsoft or somebody. But it works much better than an IP and a domain, right? So I take it, we still need to fix it. Another idea. Right now, of which one? Discord or what? No, I have no idea. I will go with half a year or something like that, or forever. I have no idea. I know that the amount of bots in Twitter got crazy, and nobody's taking them down. At least the ones of misinformation we are tracking. So I will go with everything. So, another idea? Come on, people, you're smart. You're malicious in this scenario. You need to earn money. How would you solve the problem? IPs are taken down, domains are taken down, public channels are good, but Microsoft has the bad habit of killing these ones. So you start using, I don't know, SharePoint, and they find out and take you down. I still like it. Onion networking. So onion networking, like Tor that we saw, it's also a good idea. The problem with this is that the amount of Tor nodes is kind of limit. So there are many organizations that they just block them. Because so it's like, oh yeah, you're inside my company, you don't need Tor, you're out. So it works, but for a certain small amount, right? Because remember, the good thing about Tor is that you want to use it because it's changing the source IP when you get out, right? So you go to the internet and your IPs change. But the problem here is that I want to block you when you get out to find Tor. So those IPs, how to find Tor, we have proxies and we have many, many good things that Tor is using for censorship avoidance, which are not published because it's meant for censorship avoidance. So those still work. But the bandwidth is small, and if you have, for example, like 250,000 computers, you cannot put that in Tor, right? It's just not going to work. That is good, right? So you say, hey, I go to the underworld and say, what you are, Mirai? Actually, many botnets are doing this as a side project, right? Yeah, Mirai, hey, go here and put my malware there, right? And the malware is not going to be there. However, when that malware is executed, still you need to find the command and control. Unless what you mean is that you piggyback on the command and control of another botnet. Actually, I never saw that. That could be a nice idea, like a command and control highway. So you just, hey, I will send this botnet or the other one with multiplex. Not a bad idea, actually. We need to take a note on that one. And what you are saying, I'm sorry I'm not repeating the questions. I hope it was clear from my comments. But what you are saying is, hey, if I have a malware that is infected and it's connecting and I lose connection, maybe I can find others in the network, right? And can get close to my neighbors and then kind of help each other, right? not connecting to the main, yeah, unless it's necessary, right? So this idea is actually has a name, and it's peer-to-peer, right? If you use peer-to-peer, torrent, Gnutella, or whatever, then this is how it's done. And many botnets, sorry, are using their own peer-to-peer network. So some are using Gnutella or BitTorrent, some are using their own implementation, like Sality. Sality, awesome botnet, crazy good, and it's using their own peer-to-peer. So that's it, right? And now we should go into peer-to-peer networks, which is how to fund the peers, centralized, decentralized, whatever, scan the internet, but there are options. Not the best ones, but you have options. Okay, I will tell you about another idea coming from the malware world. It's called DGA, the domain generation algorithm. So this works in this way, okay? The secret is not the IP that I'm putting in the malware. The secret is not the domain that I'm putting in the malware. The secret is an algorithm. And the algorithm is, I have a set of rules that I input something, usually is a time, okay? So the seed, the input is usually time. And then I do a magic, and at the end I create a domain. I create a domain name, okay? The domain is going to be .com. For you, it looks random. For everybody, it looks random. It's not random. It's pseudo-random, because the idea is that if I put the same input again, I will have the same domain in the back, kind of a hashing for malicious purposes. So I hide this algorithm in the malware, and then the malware runs, and the malware starts and says, okay, what is the time of the day today? Which day it is? Oh, this is the day today with this time. Takes the daytime, puts in the algorithm, and the algorithm is going to say which domain to go. And gets the domain, tries to resolve the domain. Say, hey, domain, do you have an IP? The majority of the domains don't have an IP. They're just random, right? Pseudo-random. So it's, domain, do you have an IP? And the answer from the DNS server in the world is like, I don't know that domain. So just wait 1 minute, 1 hour, take the new time, generate the new algorithm, say, what about this one? Does it have an IP? And the internet says, no. So this continuously goes, generating domain and asking non-stop until what? As the author, I know the algorithm. So I have the algorithm, I put a future date, like in a week, and I have now the domain that is going to be generated in a week times. So I have time to buy the domain, register the domain, put an IP, put the DNS servers, and then I just wait. In a week, all my bots are going to generate that domain, and when they ask, hey, do you have an IP? Internet is going to say, yeah, I do have an IP. And then the IP is going to go. And then I have connectivity. Did you get it? Was it clear? Internet, was it clear? Do we have questions? No? That's called DGA. It's an invasion from the malware authors. And let's try to see something that we can do with this. So you have here some examples. So this is a very simple example. In here we have a bash command where we are getting, let me go to my console. We are getting the date, okay, the date command. We are outputting this date command with a specific format where it's in seconds, that's the S, and then we are deleting the last millisecond, so we just keep not every second, but we keep kind of every minute, and then we get this value that now is a number, and we use SHA-256 sum, and we delete some dashes, and then we echo, we create from this domain, from the letter 35 to 45.com. So if you press enter, see, you have domains. And the domains are going to depend on the date. So that date, right, do you see that date? If you wait a little bit more, that domain will change. So please try and tell me how it works for you. I will also run this on the Strato Cyber Lab. See? And if you pay attention, it doesn't matter which computer I am, of course, because only depends on the time, right? So this, after some time, is going to change. That would be a very simple poor man's case of DGA. That's an algorithm which is only the date divided by 100, and then just use this for SHA-250 fix. It's too easy. When you open a malware and you want to see how they are doing this, the algorithms are very complex, right? Because analysts also do reverse engineering of the domains generation algorithms, but it's much more complex. Imagine doing reverse engineering of 5,000 lines of assembly doing an algorithm. Oh, super tough, and you have to get it correctly, right? So that's much harder. I'm not sure if it changed, probably will change later, okay? Questions about DGA? No? Okay, let's play a little bit about this. So I'm gonna start in my computer a very mysterious command and control server called cc.shell. That's it. That's a mysterious program. And now, in my computer, that is the IP 02, okay, 02, I open the port 9000 in this command and control server, and now you have a task. All you here in Cheveute, because we cannot do this in the internet. I will give you like a minute, and you will have to create in the same way that I just show you here, create the domain for this particular datetime. So I want you to generate the particular domain that would have been generated for that datetime, and then send it to my computer in the port 9000. Oh, we have stuff, see? Not the same. That means you don't have the correct one, 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 and you don't have the correct one. So I will give you 1 minute to see if you can send me, oh, that is the same. Sorry, I said before that it's not. Yeah, it is the same. Yes, there you go. So this is the domain you should generate. I will give you a minute for everybody to play a little bit and see how it's done. What I didn't do internet, and that's my mistake, is to put the CC content so you can play. That's my mistake. I will upload later after today so you can play in the Strato Cyber Lab with this one, okay? I will let you be there. And I'm not putting your IPs so you don't have to, yeah, I can do this. Try to play, try to see what's going on. You may need that. Maybe in the exam, who knows? Maybe not. So this is a moment. Ask questions. Yeah, the cake is a lie. Don't trust it. If you have questions, you can tell me. If you don't know what you have to do, also you can ask. It's fine. Internet questions? No? Nothing? Come on. We have 4 winners so far. There you go. Testing is good. Hi. There you go. That is good. That is good. Yeah. Okay, people. You need more time? Questions? Something happened? You're good, everybody? No, somebody got stuck on the matrix. So we are gonna be putting this shell script for the internet Strato Cyber Lab, so you can play. Sorry for that, but it's gonna be a similar one. So how to solve it? If you want to know how to solve it, you can do this. The mysterious Nasdaravi. So in this case, what you can do is that you can use the -d parameter of date to actually specify the exact date that you want date to create the date for, right? And then you just do the same. If you just fix the date in the date parameter, in the date program, then you can generate exactly that amount of seconds. And then you can do the same, okay? Very, very simple game. But the same is happening for the computers in the internet, right? And I wanted to check too, so I'm gonna stop this. Oh no, I'm being attacked. Yeah, if you remember the previous one, right? Now we have a new one. So every something like a minute, you have a new domain being generated. Of course, this for you may seem easy to detect, but this is so hard, people. DGA detection, it's an issue on the internet, and many domains that are actually good look like this one, especially domains from antivirus companies, stuff like that. You go and you say, and you see like Amazon.com and say, Amazon, why are you doing that? But yeah, it's because they need domains and they are generating domains automatically, right? So they actually look benign. So after that, what is the only issue that we have when we generate these domains? Well, you generate a domain and then I register an IP, but that IP is going to be also detected, right? So if you are very fast, you will see that some IPs are used for these domains. So that's a weakness, if you know what I mean. The domains are changing, but if the IPs do not, well, I have a limited amount of IPs. How many IPs are you going to control in your DNS server? 10, 20, 30, like 100? That's very hard, right? So the problem with this technique is the IP addresses are usually very used to detect you. And I'm going to make a parenthesis in here. Some companies spend a lot of time reversing the algorithms inside the malware. And when you have the algorithm, what you do as a security company? Well, you start generating domains in the future. So then you go, you register, you pay, you put an IP address that belongs to the security company, and in a week, all the bots of the world are going to connect to you. We call that a sinkholing, and it's a very common technique to get information from how many bots are there, and you may have an opportunity to send a command back. So if you were smart enough and you realize how the commands are being sent, if they're encrypted, which is the password, then you can connect to the bot and say, uninstall the bot, right? So also that happened. This is usually done when you are taking down some botnets, sometimes. So another technique we are going to be talking about in Command and Control is Fast-Flux. What is Fast-Flux? Fast-Flux is a technique that is also so smart. That is the following. I own 250,000 IPs of bots. That is my botnet, okay? Now, I go to my bots, and I can put a domain, or I can put a DGA, but every time that that domain is resolved, and somebody says, what is the IP of that domain? I am assigning as an IP a new IP of all my bots every time. So that means all the IPs of my botnet can be used as IP in the domain, which means that you say, which is the IP of google.com? Imagine google.com. It's like, well, it's 1111. What is the IP of google.com? 2222. What is the IP of google.com? 3333. What is the IP of that for millions? So when you do that we call Fast-Flux, you cannot block any IP because all the IPs are changing and actually used only once. So imagine the situation that you have a DGA changing domains with Fast-Flux changing IPs. How are you going to block that? The domains change every time, the IP changes every time. I don't know how to block that. That's very hard, right? And that's the techniques that the malwares are using. So let's try a little bit with Fast-Flux so you can have an idea. We are only going to test, right? It's going to be a small check. So go to your Dockers, create a Python environment, please. I'm going to also do it here. Well, I'm going to be doing, oh yeah, if you are in your class 10 lab, you may need to install the environment, but that's a very simple one. I'm going to create a Python environment here, and now I'm going to activate it. There you go. Remember, because if not, you are not going to be able to actually install some of the big packages. And then you need to install DNS Python. There you go. And then we are going to be cloning a very simple Fast-Flux check program. Okay. And then actually we need to run not this. Oh, well, we forgot to get in. Fast-Flux check. So you get in. There you go. And now you can execute it. I'm going to execute this with test.com. You can put any domain that you want, right? So in this case, it's going to say, hey, I'm checking 10 times, and this is the 2 IP addresses that I've seen. I have seen these 2 IP addresses. So the check is going to test.com, getting the IPs again, 10 times, and then doing a summary. So if you want to know, you can say, is this a Fast-Flux or not? In this case, 2 IPs are not enough for me to say this is a Fast-Flux, so this is not. So let me get another domain. Which domain we can test? We are not attacking, so you're fine. Which one do you want to test? Google.com. I have only one so far, so I will guess this is not a Fast-Flux. Which one? Malicious.com. I'm sure somebody owns this one. So not Fast-Flux. Another one? Fast with dash or without? Okay, I have no idea. Oh no, doesn't exist. What? Ha! You have an opportunity there, people. Fastflux.com. That one does exist. Only one. That's it. So please be sure that you can run this one. You may need it. The idea is how to check that something is using Fast-Flux, right? 2 IPs, 3 IPs, 4 IPs are fine. That's kind of redundancy and backup. More than that, especially if they are changing that fast, for sure we are going to be having a Fast-Flux. So what did you try? Does it work? Yes? No? Was it clear, the Fast-Flux idea? Anyone has any question? Yeah. Very good question. We didn't say. The question was, yeah, thank you very much. I have no idea how they are changing those IPs. What do you imagine? What would you need to change those IPs? Mm-hmm. So more computers for sure. I'm not sure why the VPN. Who is using the VPN? The IPs, I'm not sure. Well, actually, sometimes it's like 10 times per second. So what is the problem? If you go to your, first you need to own the domain, right? If you don't own the domain, you cannot change the zone of the domain. So you need to pay, own the domain. And then you need to own the DNS server. Some hosting providers give you access to the DNS server, but this is for changing once a year, right? Oh yeah, that's the IP. What you need is a program. You need to run the program of the DNS server. So normal DNS servers don't change that fast because you have the issue of the cache, right? Usually the DNS is cache, and every DNS in the middle is gonna remember it. So even if you change fast, everyone else is going to remember the previous one, which is not good, right? So when you control the DNS server, then you can define the cache, which is usually 0. So do not remember this domain. And then you modify the DNS server to put the IPs every time. So you have to redo the DNS server. So every time somebody's asking, you give a new one with the cache in 0. And then nobody remembers it, and everybody is forced to ask you again. You can put any IP address you want. You need just to control it, right? Because what the malware is going to do is like, hey, I'm going to generate this domain. What is the IP? I get a new one. And then it's going to connect to some protocol. I don't know, HTTP. So I need that when I connect with the command and control protocol, the protocol to be working. So that's why usually the IPs used are belonging already to the botnet. So what you need is to build up the amount of bots. You make them part of the Fast-Flux. New ones connect. And actually, the strategy is like some percentage of your bots you dedicate to Fast-Flux, some percentage to spam sending. So it's a business, right? Some percentage for creating new and infecting. Because if you use everything for every bot for everything, they're going to be blocked very fast. So for example, the case of Mirai, right? Mirai is scanning and brute forcing, but the IPs that are scanning and brute forcing are not the same that are connecting later and infecting you. So they share the information. It's like, I already scan, then I share this with the network, and somebody else is attacking, right? Which is pretty smart. Question? Something more? Fast-Flux? No? Okay, let's go. So examples of protocols that were converted into command and control channels. You can use whatever you want, people. The most common are actually using TLS. Why TLS? Why encrypted HTTP is the most common one? It's the most normal, right? You go there, everything is TLS. It's encrypted, and then you have everything there. Very hard to detect, very hard to detect. Inside the encryption, you don't care so much because it's encrypted. So you have stuff like status up, right? This is very easy to do. So you have straightforward commands when you see, you say, yeah, it's checking if the status of the command is of the command and control server is up, right? Or something like this. Status updates are easily done with steganography, right? Since it's a binary update. So the heartbeat or the status, are you up or not? That's easy. You can say, do you want to send an email? Yes, no, yes, no. So you can do encoding, you can do a lot of obfuscation in here. Usually it works, right? So do you remember SNIs, the server name identifier? Do you remember we were talking about these ones when we were saying how the browser goes into a web page and how the encryption in TLS works? Do you remember? Class number 1 maybe, or 2, I'm not sure. No? SNI? So, very fast recap, maybe for the internet too. So when you go to a web page that is encrypted, you want to encrypt, okay? But to encrypt, you need a certificate, because in the certificate you have the public key. So when you go, you say, hey, I want to encrypt. And the web server is going to tell you, okay, I need to give you the certificate. So to which domain are you going? Because if you don't tell me which domain you are going, I don't know which certificate to give you. I have many domains. But as a client, you say, well, I want to encrypt before sending you an information. So we are in a lock. The solution is the SNI. It's a field in the TLS protocol where you put which domain you are going before actually going. So you connect to the web server and say, SNI it's google.com, unencrypted. okay? Unencrypted. So the web server says, oh, you want to go to google.com? Awesome. Here is a certificate. Gets a certificate, you get a public key, you do your magic, you start encrypting, and then you encrypt some symmetric key, and then you have transfer data. When you transfer data, you actually do HTTP, and you put the host header with www.google.com, okay? But the SNI, it's unencrypted in the TLS protocol. So, for example, right, one idea could be the bot asks for different SNI subdomains to report, and the command and controls are different certificates. That would be a very weird and hard to detect command and control. Every time I'm going to the web page, it's like, oh, I would like to go to pepito.com. Doesn't exist, it doesn't matter. And the command and control is like, oh, pepito.com? Yeah, got you. Blink, blink. You are asking me which are the new spam addresses. So, oh yeah, sure. Here is a certificate for you, right? So I have no idea what's going on. When I look at the communication, it's asking pepito.com, and then there is a certificate going back. Nothing wrong with that. But the botnet is already sending data. So that doesn't exist. That's some idea we put in there, but that would work very well, okay? So using host names, ordinary IP, a lot, is easy to encrypt. So HTTPS is very, very good one. Also, you can do a custom port and protocol, very common in botnets, right? The bot masters go there and they're like super hacksaw, and then I'm not gonna use HTTPS. I'm gonna create my own protocol because I'm super programmer. So you go and you have a very weird protocol. What do you think about this one idea? Do you like custom weird protocols, or do you prefer HTTPS, for example? Would you implement your own super duper protocol as a malware command and control? Yes? Huh? Easy to detect people. It's super good. Hey, go do it. But it's very going to be easy to say, you are weird. You are not a part of the normality. Oh, I don't understand you. I don't care. I just block you, right? Yeah. Huh. Exactly, exactly. That's super good, right? It's going to take them very easy to see if they're the same. And actually, if you make a mistake, or even if you program in a very specific way, they may know that you is you, even the same developer. So I know it's good, you can try, but don't implement a real botnet like this. It's tough. So then you can also, of course, do this in domains. Remember, we are using examples of protocols that were converted to command and control. So we can use DNS. Why not? Not DNS for resolving. DNS for sending data and receiving commands, right? You can use whatever. So how would you use that one? How do you use DNS as a command and control protocol? For example, right? So it's like, oh, do you know the IP of the domain .pepito.com? And in that, I can encode whatever I want. I can put instructions. I can ask for commands. It's an encoding, right? And then the command and control server, the DNS server, is like, oh, yeah, sure. You want to know something? Here's the TXT record, right? Remember TXT, one type of record in DNS? You can put whatever you want. And you can encrypt, and you can encode. So that's very much used, very hard to detect. And actually, the official name for this is DNS tunneling, which is using DNS, kind of a VPN. Actually, there are VPNs over DNS, which are very successful because nobody's blocking DNS. So you can go to these places. You know these places, coffee shops, airports, hotels, that you have a Wi-Fi connection, but you cannot go to the internet until you pay? Well, the only protocol that can go out without paying is DNS. So if you have a DNS tunnel, you just start your DNS VPN, and you have free internet without paying. That works. A friend told me. It works very well. So DNS query, yes, domain is controlled by the attacker. That is very easy, right? For example, look at this one. Let's execute this code. So this is a bash code. And in here, we are creating a variable A. and we are putting in this variable a sub command of bash, and the sub command is echo get order, and then pipe to base64. So we are doing a base64 of this, and we just output that .mydomain.com, and that's it, right? That is not DGA, that is not random, that's DNS tunneling, because I'm sending something specific, and you can actually decode it back, okay? So it's very hard to distinguish DNS tunneling from DGA. And then, yes, you can add compression, you can add encryption, all you want in here, right? Another example is DOH. I'm not sure if you know DOH. DNS over HTTP. Remember the first class, DOT, DOQ, DOH. So DOH is DNS over HTTPS. First you do the HTTPS request, and then inside you do JSON. So that's it. You can use this as a command and control, no problem, right? Nobody is gonna see. You can use IRC. Do you know IRC? Anybody? No? IRC? So sad. I'm so sad. We are losing something here. Huh? Yeah. Oh, we should do a break soon. Okay. What was the break? For half? Okay. So let's. Okay, we are almost there. So let's finish this part, and that's it. IRC, Internet Relay Chat, a text-based protocol that is kind of peer-to-peer, one of the first chatting systems of the internet after Usenet and bulletin boards in the 70s. The first protocol we created for chatting online is IRC. Crazy awesome, still alive, still working, beautiful. Many, many people use it. And it's free, and it's distribute, no company. So you don't have some Discord around that can take you down. Internet Relay Chat actually is the origin of the bots. We are going to be using it today later. Peer-to-peer, we already say. What about Bluetooth connections? You can do command and control there. What about air-gap computers? That computers that don't have Wi-Fi or Bluetooth or anything, right? Completely separate. Well, you can do, for example, audio connections. We have a thesis of one of our researchers, Aleya, when she was doing her bachelor thesis was about using sound to communicate between two computers and transfer data. So you cannot hear anything, like, but then they were encoding the instructions in sound. So you have a microphone, you have a speaker, that's it. We can have a command and control here. And of course, many more, including social networks, as said before. And cloud, because cloud is all the domains we have now. So cloud is getting all together, okay? Okay, let's make a break here, and then we continue in 10 minutes, okay? For 52, so 02, we are back, internet. Bathroom time if you also want internet. And see you later. See you later, alligator. Okay, let's go, people. Let's go, people. Internet, we are coming back. Leave the dog or whatever you're scratching. I have weird imagination what the internet is doing during these classes. Let the cat come. Pause the series on Netflix. We are going back. Okay, so now let's put a little bit hands-on on a working command and control communication channel, okay? So we are going to be using a Python botnet that is going to be working from somebody called Happy Stoic, a known internet user. Simple command and control botnet written asynchronously using Asyncio. Do you know the Asyncio library in Python? Awesome library. So it's like doing asynchronous communication. And the communication is implemented using unencrypted WebSockets. So a lot of weird technology here, okay? If you don't know WebSockets or asynchronicity, you can go and try. So this is what's going to happen. You're going to have a command and control server that you're going to be executing. Also internet, you're going to be executing locally. And then you're going to have bots. In the case of here, Cheveute is going to be yourself the bots and yourself the servers. In the internet, you're going to be executing the server and the bots too. And then as a bot master, which is the owner, we are going to be using a special a special command, command called wscat to connect to the server, but to administer it, because this is the first time I say that, but the command and control server has two ways of communication, one with the bots and one with the owner. Usually different protocols, different strategies, okay? So be aware there. So online students, you need to install, oh, you don't, right? Anymore, npm is installed or not? Let me try. npm, oh, did I did something wrong then? Maybe I did something wrong. Oh, okay, it should be working for you. I'm not sure, maybe I didn't, oh, I didn't put the main. I have the other branch still, the class 10 branch. My fault. So if you're online, don't worry, the commands will work for you. If not, you have here how to install. So first you need to create an environment. Also, this is for you, CVUT. So go and create an environment. If you don't have it yet, if you have it, awesome. And then, yes, activate the environment. There you go. Activate the environment. And if you don't have, you should install the wscat, so you can try to install in your computer. It's going to be very fast. I think it's already installed. That's it. It's correct install. But just in case you can try to. Yeah, here I don't have it, but you have it on the internet. So I'm going to be doing this on the CVUT repositories. So let's clone the repository of the Python botnet of Happy Stoic. I already have it there. So I'm not going to, I can delete it because why not? There you go. I'm going to clone again. And then after that, you get in the Python botnet folder, and then you install the requirements by doing pip install dot. Okay? There you go. Should install everything. I will give you 20 seconds to make it happen. Internet, also you should do this. Internet, you should do this in the computer. It can be any computer in the Docker. In this case, I was going to do it in the class 10, so, which is fine. Okay, so we are going to be doing everything in one computer, internet, so it's easier for you. Okay, everybody? Issues, error, warnings? No? Okay, so let's start the server in the background using Tmax. So I'm not sure if we do this before. In Tmax, you can execute Tmax with the command that you want and just let it go in the background, so we don't have to get in and then get out. So it's a little bit more pro. So that means Tmax, new session, go into the background, and then put as a name botnet server, and the command we are going to be execute inside is going to be the exact place where you have the server installed. So if you do that in your CVUT, you don't realize, but if you do Tmax ls, you should have there a botnet server running, okay? So everybody please run a server, because we are going to be using your friends around. And internet, you should do this in the class number 10. And then we are going to be starting one of the bots. So to start a bot, we want to connect to somebody else in the network. So remember some of the IPs of your friends, or you can go and pick up some of the IPs of your friends, and we are going to be using that one. In the case of the internet, just connect to yourself, okay? If you are here in this computer, this is 172.20.0.125, so you can connect there, okay? Internet, you can run this in there. So I'm going to run this, and now I'm going to pick some of you randomly, because I cannot access my matrix, and that's it. I'm not sure if this works, right, because it's already in the background. So actually, you can check. You can do, hey, Tmax, I have two. Can you try to connect to the one called botnet server? No, sorry, botnet client. And then it's like, oh, yeah, see, connection call failed, so that computer is actually not available. Okay, I will stop and I will connect back. Or somebody can tell me one of your IPs if you run the server. Some IP? 19? 19, and let's check what we have. Starting the client, it seems that it's fine, so you should see a client later. And if somebody connects to me, I will appreciate it, because I need to control some bots. So Do you know what we are doing, right? The server is the command and control. The rest of the bots are connecting to you. On the internet, you have the server and the bot in the same computer because now we don't care so much. We just want to control it. Now, for being the bot master, you need to connect to this command and control actually to control it. So we are going to be using the wget command, and we are going to be using the protocol called WebSockets, that's WS. In the case of the online students, you connect to yourself, like I told you. In the case of you, Cheveute, you can connect to localhost because you want to connect to your own command and control server, right? So you say localhost, and look at that. You should be able to see, well, not here because it's horrible, but you should be able to see the interface of this homemade command and control server. So you say, hey, enter 0 if you want to print the bot clients collection, enter the index of the client separated by space to send bash commands to, or the index of one client to jump into a bash. So here you can have many bots. Oh, look at that, I have 4 bots. Oh, that's so nice. So I have 4 bots, and now I can actually connect to any of those. For example, if I put 2, I'm going to pick the one called 29, enter, and then I can do stuff like processes. And those are the processes in the bot, okay? Yeah. Yes, I can. Thank you very much. Thank you very much for reminding me. So I'm going to change this to daylight. There you go. And then, better? There you go. So I press 2, and then I'm now talking to 2, and then I have the commands. But, and if you do Control-C, you leave, okay? But if you connect again, for example, I'm going to connect again, and now I can actually put, so how many do I have? I have 4. I can put 1, 2, 3, right? And then I can put PSFX, and I have the command execute in all the bots. So this is another way for having actually kind of a custom protocol using WebSockets, so still web, but WebSockets, and the bots connect to you, and then you have control of the bots, and you can execute commands in all the bots simultaneously. So please be sure that it works for you. You should see many of you, and if you don't have enough bots, you can tell me, I can be your client. So who can tell me somebody needs bots? Somebody wants me to connect and you can control me? Really? Nobody wants to control my computer. We're having an issue here. You? Okay, what is your IP? 9? There you go. We have a bot. Oh, yeah, duplicate session. Yeah, I know. Who cares? There you go. Oh, it didn't like it? Okay, bot client 2. Is it fine? There you go. Now you should see me. Somebody else needs a bot? Uh-huh. And can you check that the server is up and you have any issue? So if you do tmax and you connect to that one, botnet server, right? Yeah, user root remove, yeah. You can have something like that, but usually it should be working. In my case, it is. So you can do, wait for me. Come on, computer, you can do this. When you start it, then you can list, and then you can just do A to attach, and yeah, and T. Okay? Oh. Okay. Okay, Martin is checking. Ah, you have a wrong node version. Okay, so in that case, you can update the node version. So if you do apt update, and I can put it here, let me see. CTU, if you do apt update, and then you do apt install Node.js, you should have the new one. That's weird because the majority had the correct version. I don't know what happened. Apt update. Okay, try to see if the new version of Node.js can make it happen. Okay, so this is funny, but exactly one of the reasons why you don't want to implement your own protocol, because these things like different library versions, different Python versions, check the Python version too, these are the difference you are going to encounter in all your bots. Remember that the bots are, I don't know, 100,000 computers all over the world. That means Android, Linux, Windows, all computers, new computers. So actually executing your malware is very hard. That's why the more you use traditional protocols, the more you're going to be able to make this happen, okay? And also in the internet, if you have issues, tell us, okay? So once we have this is an example, and you should see something like that to run it, right? And actually, it's very nice practice because this protocol here, this command and control was one of the assignments of one ex-student of this class. So when we did the, oh yeah, you have to create something, they were creating this one, which actually works very well if you have the correct libraries. So that's another example of a command and control channel that you can implement. And this one in particular is very hard to realize because it's using the web protocol, okay? Yes? Even the Node.js? And which version of Node.js you have? Okay, perfect. So the solution is going to be on the matrix. I have 2211 just in case. Aha, that's why. Now, if you don't have a like update library, no, I'm sorry. I'm not sure why, because usually like update, but maybe some things we are missing in there. Thank you very much. And the internet, if you have also issues, tell me, but you should not if you implement the latest version. I mean, if you pull the latest StratoCyberLab. Okay, questions about this command and control? Questions about the real? You can imagine, you saw that this is handmade, right? Because you have to put the IDs of the bots, which is not practical. So how many bots can you control with this program? I don't know, 20, 50. After that is too much, right? And also you don't have a good tracking of which ones are dead, which ones are not. That's why the majority of the command and controls go to the web. And then you have a web page with graphs and ups and down and everything, okay? So have it in mind, because when you have to do your own command and control, you are going to be solving some of these problems, okay? So let's jump into the last topic today, that is using the Lightaidra botnet. This is the last one because this is a real botnet, people. This is not simulation. This is not us doing Pythons or something. This is a real botnet that you can find in the world and work for a long time. And it's right now still alive, but having less and less bots because it's using IRC. And less people is using IRC, and less IRC servers are available. So this is more complex and a realistic setup. And Lightaidra, yeah, it's based or was based as the basis of many, many IoT attacks, and it did a lot of issues in the past. So it's a mass tool commanded by IRC, Internet Relay Chat, this chatting protocol I was telling you that it's based on text, and it was allowing for scanning and exploiting routers, yeah, and it was doing a botnet out of this, okay? And especially the attacks, a lot of DOS attacks. We are going to be doing some of them today. So for this, you need to have IRC servers. That's Internet Relay Chat servers that you connect. And then you're going to be using those as a command and control, okay? So you don't have to install, maintain, or update any server. It's going to be using actually a public service like here. How is your name again? Lucas was saying. That is like, I'm going to be using something that already exists, so I just need to connect there. So, brief about IRC. It was not, you should have connected not as root. Maybe now it's too late. I'm sorry. Somebody steal everything. I'm so sorry. No, you should not. But you should have done that with some Pedro user, probably my mistake. Yeah, I probably will put it here so I don't forget the next time. This one here, right? Yeah. So I would say be Pedro first, yeah. then I will check it. Thank you very much. But no, maybe also delete everything very fast and stop all the servers and bots in your computer while you have time. Going back to Lightaidra and IRC. So IRC, this communication channel, was born a long time ago. It was maintained by a network of networks. So what the people did is that they installed IRC servers, and then these IRC servers had clients. You connect to one, and then everyone in that computer can chat to each other. But I don't want to chat only with the people, I don't know, in Argentina. I want to also chat with the people in, whatever, Uganda. So all the IRC servers connect to each other. So it's kind of a distribute decentralized network. So when I go to this channel, to this network, and I want to chat, imagine that I create a channel called Security People, let's talk here, right? So that's the name of the channel. When I create that channel is shared by all the clients and all the servers in this network in IRC. So I don't care where you are or how you are, we are going to be sharing this. Right now, it's easier to understand because we are used to Slack and Discord or even Matrix, but Discord is a private protocol by a company and it's centralized, right? The closest we can get is the Fediverse. So Matrix and Element and these protocols are distributed and federated. So IRC was the first federated network, which means I have my own server, but I can connect to another server, and then we share the clients and we share the channels. So this happened in the 60s and was awesome, still awesome. Most importantly for me is that it was so important that CBUT has one of the biggest IRC servers in Czech Republic. Still, the university maintains this, and you can go there, connect, and chat. That is how important this was in the past. The thing is that right now, what's a big, I don't know, Slack channel? I don't know, 5,000 people, right? In Discord, you can have 1,000 people in your channel, no issue. It's not common, but you can have some gaming servers. You can have, I don't know, 10,000, 20,000, 30,000. And in a lot of these networks, you have to pay because it's hard to have 30,000 people talking in your channels. In the 60s, we were able to use IRC, and you very easily can have 500,000 people chatting, no issue. And we were able to do that in the 60s for free. So it's a little bit weird that now we are paying 60s. 60s? What is this? Can you check? What is the IRC? I will go no more than 70s for this one. So we were using IRC for, I don't know, huge amount of people for free, but now we have to pay for service. When? 98. 88. Oof. 18 years wrong. I'm sorry, people. I lied to you. In my mind, was 60s or 70s. Wow. So 88. Confirm. If not, you can talk to Lucas here. 88. We were able to do that. No issue. So now we are going to be using IRC for our real botnet. Okay. So yes, there you go. Yeah, Matrix is a similar protocol right now. So this botnet, how does it spread? It spreads like most IoT botnets, which means scanning, 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 brute forcing, brute forcing, brute forcing, attacking, 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 getting the bots, and executing itself. The same is with Lightaidra. So for online students, you have two computers that are the bot. We are going to be using those with you. For CBUT, we are going to be all of you connecting and getting the bot and getting into the command and control server and managing directly, okay? So all of you git clone the Lightaidra. Yeah, I already have it. I will delete. '88. Wow. Get into Lightaidra. The same for people here. So if you are doing this in the Strato Cyber Lab, you need to run this in your bots, okay? So first connect 192.20.0.131, right admin, and then git clone, and then get in. And then we need to create a folder called bin, so mkdir bin. Okay, there we go. And now we need to configure this Lightaidra that you have to compile because it's C. So the configuration is this include config.h. So please edit this file so you can have the configuration of the bot on the botnet. So all of this is only for the botnet. And the most important piece of information to change here is the IP address of the IRC server. So this one that says define IRC servers, we are going to change. And everybody, CVUT and online, you need to change this to the IP address 172.20.0.130, okay? That's the IP address of the IRC server that we install in CVUT and that's installed in the Strato Cyber Lab, okay? So please go there and change that IP address. Also here, I'm going to do it in Strato Cyber Lab. Okay? The rest of the things that are important here are, I will go here just because of the light, are if you need a password to connect to the IRC, in this case you don't need, and then you can even encrypt the list of servers if you want. And the other important piece of information is the IRC channel. So the channel is the place where you're going to be talking with other bots. And you can change this right now to whatever you want. This is your bot and your botnet, so feel free. I'm going to be using that one so we share the bots and we can see many bots, okay? So if some of you leave that, would be awesome. Online, you can also use the same channel because it's local in your Strato Cyber Lab. I'm putting here a random one because we used to do this in IRC servers in the internet and I didn't want everybody just to find the channel, right? So it's kind of a hidden channel. And the other piece of important information is this one here, the master password. That is the password of the bot if you want to control it. So if you do not know this password, nobody can control the bot. That's a security measure. So in there, if you want to control your own bots, you can put your own password. If not, you're going to use our default password. The same for the internet, okay? So that being said, here, more things. With this command, make x8664, we are going to compile. So get out, press enter, and let's compile this. Okay? Compile. After the compilation is done, we now need to actually execute the bot. Okay? Execute the bot. So we are going to be using a new tmax, so we don't, control our terminal. There we go. And in this tmax, we are going to get into Lightaidra if you are not there already. And then this command executes the bots. Bin x8664. This executes the bot, okay? So when I'm doing this, now my bot is going to connect to the IRC command and control server. There you go. And then it's going to just stay connected, okay? I already have 10 clients there. So that's it. I will try to do the same here. I will connect. No, I need to do the tmax, new, and the T is going to be bot. And then I'm just going to execute. There you go. So online, I also have my bot running. Yes. And now, how do we control the bots? How do we actually do this command and control thing? Well, we need to connect to the IRC server and be the admins. And for that, we are going to be using an IRC chatting program for the console called WeChat. So if you go to your console and you press WeChat and you press enter, you will see a beautiful, beautiful user interface for chatting in IRC. And the same you can do here. Actually, I will get out of bot, so this should be in your class 10, okay? Oh, we don't have WeChat, yeah, because this is my problem, sorry. Install WeChat, I think it was like that. Oh no, install, did I? Oh, there you go, yes, install. This is because I'm stupid and I have an old version of the lab in my computer. So there you go. So once you are there, yeah, because you are going to be connecting as an admin, you can also run this as user Pedro, right? We were saying before about that. So you can run as Pedro, no problem. I'm going to run as root because I'm the controller now, so it's not so dangerous. But if you would like, you can run this as Pedro, and you do exactly the same, but with Pedro. I'm going to see if this is installed. There you go. So WeChat, do we have WeChat? Perfect, we have WeChat. So, everyone in WeChat? Yes? WeChat, chatting program that we are connecting to the IRC server. In that IRC server, already the bots are connected and waiting for us, okay? So, how do we connect to a server in this interface? Well, the first command we need to put is we need to define a new server. That's the /server command. In this case, I'm going to call the server called my server with that IP address. That's the IP address of the IRC we install. And then with /connect, you connect to the server. And look at that, WeChat, and something there, very fast. Oh, root is already in use, root 1, root 2, 3, many roots connected, so it's giving you a new one. And they have 22 clients are there, current local users, 9 channels form, 1 and no connection, right? So very nice chatting in the IRC. And now we can join a channel. I'm gonna join a channel so I can see all the people chatting. So there you go. See, oh, hi, this is a chatting program. How are you? This is what we used to do in 88, apparently, because this is not the 70s. But you can see that the users are at the right, root, and Pedro, and these are the bots. Can you see? Many bots in here. So those are all the bots. And the @ symbol, this symbol here, identifies the administrator of the channel, who is the first user to connect. In this case, this is a bot, okay? So, very complex protocol in IRC. You can have connections one-to-one. You can have video calls. You can have file transfers. You can automate. It's ASCII-based. Amazing, amazing protocol. So, how do we control the bots now that we are here? How do we control the bots? Well, we control the bots by logging in. So you do -login. This is not IRC anymore. Now it's the botnet protocol, okay? -login, and then the password. That was test 1, 2, 3, okay? And now, oh no, everybody changed the password. I cannot log in to any of those bots. Bad people, bad people. So I will try with the Stratosphere Cyberlab, since they changed my passwords. I will create my server there. I will do connect server, and then I will join my channel online. I'm alone in here, so let me start my bot again, /quit to quit. I'm gonna go to my bot and start it again, and that was admin, and that was start again. Where are you, bot? Here. You are here, bot. Yes, you are dead, bot. There you go. And now I'm WeChat. And now I'm gonna connect to my servers. I'm not sure if I have the server already. Oh, there you go. And now I try to connect. Oh, I think that my bot. Oh, because I have the old version. Ah, okay. I will stay here. So. Yeah, authentication wrong. The people changed my login password. So I'm going to try again to see if a new bot arrived. And if I check here, my password was 123, test 123. I don't have it. Okay, test 123. 1234. Ah, that's why. Login. Thank you. Test 1234. Oh, has joined. Oh, that's a new one. Current not working. Okay. Oh, look at us. We are all trying to control the bot simultaneously. This is going to be a challenge, right? So we have like 10 command and control masters, and we have 10 bots, and everybody's giving different questions and answers. So that's so nice. Among the things you can do is like check the status. Let me see the status for me. What are you doing, bots? And the bots, if I log in correctly, it's like not working, not working, not working, right? It's okay, bots, you're not working. So let's do something. Among the things you can do, you can check the code of the botnet, so you can have many, many, many things. For example, you can execute commands. You can actually do advanced scans, port scans, recursive scans, random scans. You can do denial of service, which actually work very nice, floods and spoofing and many more. So this is a complex botnet with many protocols, and we are not going to be using all of them, but we are going to be using some. Before using the commands, we have password time. Eee! For the people online. So today, the password of class number 10 is clickbait. 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 Got it? Tan 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 tan. That's it. Out. So after password time, let's start with the first command. The first command we are going to be doing is advanced scan. Advanced scan is doing a scan of a B network, which is a huge network, 65,000 hosts, of port 23. You can change that, but let's do 23 first, okay? So how it works is that you need to give the first 2 octets of the network, and then it's going to scan all the hosts in there. And it's going to be first an ARP scan, and if not, it's going to be doing a direct port scan, okay? So be careful here, and please only scan our local network. Oh, actually, this is 20. That was my mistake. So if you do advanced scans 192.20, enter, it's going to start doing something, and then I'm going to check the status. Hey, status. And the status should be something like, I'm scanning. Wait a little bit, right? We will see what's going on. I think that we are giving many different instructions. And also what I will be doing while I'm doing this command is that I'm going to be port scanning. Sorry, I will be password sniffing. So TCP dump, and I will say here port not 22. And see, look at that. We have like ARP people that are trying to scan the whole time. So that's your bots, right? That's the bots trying to do ARP scan and connecting to us, all of us, right? And even from time to time, yeah, we have 6667 and maybe others. So yeah. Oh, yes. Working on advanced scans range. Also, you can see the status there. Advanced scan range. So be careful because it's powerful and you're going to be scanning a lot. And if you do this with 10 computers, easily you can take down any server. If you have 10 computers like here and you scan something, it's going to be complicated. Okay? So use with responsibility. And please do not scan the internet from here. We are going to have issues. And then if you want to stop the scan, right, you do .stop, and then operation was stop. Everything stopped, right? And that's it. And yeah, we have other advanced scans. So in this case, for example, you can also do a DOS attack, right? So let's only try 5 seconds. So that's the last parameter. So SymFlood, some IP, 10 is the port to scan, and then 5 seconds, right? So if you do that, it's going to be a very fast SymFlood that is not going to be dangerous because it's too fast, right? Packaging complete, and that's it. So if you are in a local network, for example, and you do that with bots, easily losing the connection, okay? we don't do it here because we are going to be losing the connection to our SSH. Okay, and then of course you can just, in case of emergency, stop everything. So you can go to your bot and you can stop it, right? So please do not leave your bot unattended because it's an issue. So you can quit here, and then you can go to your bot. I don't know which sessions I have. I have bot 5. There you go. This was kill. And then I have other bots. So please clean your computer. I have 2 botnet client to stop you, botnet client to stop you. Okay? So be sure that you stop your bot so others are not abusing your bot. Okay? And I want questions. Questions? What happened? What do you think about it? That's a real one. It may seem weird that this is a real botnet, but it was, and it had thousands and thousands of bots. No problem, because they just give orders, and then they say, okay, send the commands here, 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 and that's it. You can talk to each bot if you want. You can execute commands. So these people was managing thousands of computers, no problem with this one. It's not super advanced. Now we have much more advanced, but it's a nice example for you to analyze. The problems with the more recent botnets, that is much harder to try in a laboratory, because you need then to have the code, and then you need to be able to compile and to modify and to start the server. And usually the botnets that are being leaked are the client side, never the server side. So you may have the code of some botnet when you are infected, but you never have the command and control channel. So it's very hard to mimic it. In this case, because it's IRC, it's much easier, right? Questions? Yes? No? Maybe? No questions? Okay, advantages, disadvantages. Be careful with the real IRC servers when you use. You're going to be banned. The people is doing this since 88, so you're going to be banned, okay? Be careful when you're using real servers. It's not easy to allow multiple bots from a same IP. So one of the issues we have every year is that when all of us connect to a real server, the server realizes and says, yeah, you cannot have 80 computers from one IP. You can have maybe 2. So it's very hard to do that, right? Also, they will check if your IP is white blacklisted. That means every time you connect to an IRC server, they're going to scan you back, which is weird, but they're going to scan you back, no problem, okay? And then, why it's good about IRC? Well, it's very easy to implement, people. It's ASCII. You can do an NCAT and chat here. So no complex library, no complex protocol, no Node.js that you need to install and update. Any computer in the world that can send text can be infected, which is very, very important. So you can port this to any architecture. IRC, we have in many protocols and others, okay? So, and actually, IRC in the 88 was the first time that we needed to automate things. For example, to ban people, to say, the common one was, I have a library of books. Do you want a book? So I program a bot that you ask for a book and it's giving you the book. So those were the first bots ever. The first bot from botnet comes from the bots in IRC. That's how important it was, okay? And what is bad? Well, it's ASCII based, so no encryption. Be careful there. Authentication is possible, but very hard in IRC. And it's very easy to detect. We know this one. And there is no compression, people, okay? So we have some issues here at all. So we are going to stop here. We are already on time. We have an assignment coming this week. Do you want to give it?
Yeah, sure. So this week's assignment, as usual, opens at 9 p.m. tonight. This is going to test your maybe coding skills a bit. We're going to have a server running. You have to create a client, connect to the server, and the server will be giving some tasks to your client. The client needs to be able to do those tasks, and if you do them, you get the flag. Of course, we have a way to check if you're doing it manually or you really have the code running. So for that, we have this proof of work. You will also be given this in the CTFD. So the server will give you some task that you have to complete in a very short time. So that's a way for us to check that it's actually code running this, that it's automated, not you manually doing the tasks of the server. And we will release a hint on Monday, which will cost you 3 points if you use it. So we are releasing it on Monday, so it doesn't interfere with the Pioneer Prize for the people playing, for the prizes. And the hint will give you like a skeleton of the code for the client, and then you will have to fill it in. So, do you? No, you can do it later than Monday. If you don't use the hint, you don't lose the points.
Yeah,
so
it's an optional. If you don't know how to solve it, it can be hard. So you say, I want my hint, you click, and then we give you a hint, but then you forfeit 3 points of the final points.
So is it clear what you have to do with the client and basically create it, connect to the server and do stuff?
Questions? Is it clear? No? You need to repeat it? Do you understand what is that for?
Sorry, this is the assignment 8. We just,
Yes.
It's a
Of course, see?
typo, yeah.
What did I miss right now? So, and also, Martine, do you want to say something about the Strato Cyber Lab? So that is for you. If you have questions, people, tell us.
Yeah, and there's also a new challenge in Strato Cyberlab, so you and also online people, you can play. It's called Cybernet, and if you were listening to Maurice, it's very similar. Not the same, but yeah, you have to implement a client and understand the protocol of C&C server. Yeah, I think that's enough.
Okay, that's enough hints for the Strato Cyber Lab. So people online, you have a new challenge. And 2 more things. One more thing. The feedback, please remember, very important for us. And this week, we have a special request from you. If you remember the class we did on honeypots, we would like to have a questionnaire for you here and from the internet. So we have here a 5-question form about honeypots that we need to know. If you can help us getting these answers, it would be awesome and beautiful. We just need your help answering those forms. That is in relation with the class of honeypots that you have with Maurice, okay? So if you can answer the form during the week or today or something is fine, and the feedback, both the internet and here, okay? So that's it. We are gone. Thank you very much, people, and see you next week. And enjoy. Bye-bye. Auf Wiedersehen, goodbye. Goodbye. Ciao, internet.